Tide strongly believes the importance of environment protection and energy efficiency in order to achieve a sustainable future for mankind. Thus, our technological commitment will foster mutual betterment of our allied companies, customers, shareholders, and employees. Tide pledges to always hold our management philosophy and values at heart. Until now, the meter readers have had to do manual meter reading. This existing manual process is time and money-consuming work. This makes it hard for us to detect blackout and manage energy demands. And it makes us hard to manage loss during transmission and distribution. As a result, this existing manual process makes grid unsmarter. But Tide's end-to-end AMI solutions will connect the user with utility companies. Tide's intelligent AMI solutions will solve many problems from the existing manual process. We can reduce time and money spent metering manually. We can manage blackout and loss during distribution. We can do demand response, TOU. Finally, we can make grid smarter. AMI service. Meter reading information of household is call-seated by modem and DCU. There are two types of smart meter, internal and external. Smart meter sends metering data to modem via serial communication. Modem sends metering data to DCU via PLC communication. DCU sends metering data to server via fiber optic and cellular network. On-time monitoring and detection of electrical loss. TOU, time of USC flexible tariffs. Connectivity to electric vehicle charging system. Connection of renewable energy and battery with bidirectional metering. Reliable collection rate improving monitoring of power quality. Making grid smarter and more efficient. A hidden champion in the energy IoT solution industry. Tide.
It's easy to be blinded by the urgent issues facing our planet. But to shut our eyes is not in our DNA. We look at problems not as one big challenge. We break them down into a spectrum of solutions. Leveraging our pioneering and digital technologies to co-create innovative solutions with our partners and customers across the entire value chain. Powering efficiency by creating a smarter, more flexible power grid. Powering resilience and reliability by digitalizing the energy value chain. Powering safety by enabling cyber-secure infrastructure for mission-critical sectors. Powering sustainability by integrating renewables into the power grid. We are two pioneers combining generations of expertise for a stronger, smarter, and greener future. Powering good for sustainable energy. Hitachi ABB Power Grids.
Power has changed everything. The progress of people depends on it. But this has impacted our planet too. Where do we go from here? Do we restrict energy to protect our environment? Or do we keep using energy to drive our progress? How do we solve this? We need more options than we have today to solve the challenges we face. Because the right answer isn't a single answer, and it isn't a simple answer. At Mitsubishi Power, we are imagining new possibilities. We are constantly innovating new technologies to make the energy we need to thrive not only better than ever before, but different. Our energy solutions are as diverse as the communities we serve. For more than 100 years, we have applied innovative engineering to bring power to people everywhere. Today, we partner with our customers in every community as they build their paths to reliable, affordable, and decarbonized power to make a cleaner and happier world. At Mitsubishi Power, we are creating a future that works for people and the planet.
E is the beginning of change. E is a mission for the planet Earth, not just a new business. E is the power for a sustainable tomorrow, not just a source of power. E is a challenge for a better future, not just about adapting to survive. E is an innovation that turns imagination into reality, not just an everyday thing. Far beyond the great history we have made, becoming a global leader in smart energy. We are reborn anew. LS Electric.
If you're following the worldwide increase of clean energy sources, you may have discovered increased buzz around energy storage and renewable energy. What you might not know is that energy producers rely on sophisticated energy management platforms when integrating these innovative energy options into their existing power systems. Take Wärtsilä's energy management system, GEMS. Combining multiple data sources, GEMS uses algorithms and machine learning to automate decision-making for power producers. It ensures the energy system performance is always optimized, no matter how many renewable and traditional energy sources GEMS combines. Wärtsilä GEMS has been refined to build, monitor, and intelligently operate power plants and energy resources. GEMS has become the leading smart energy management software that benefits energy producers in their daily operations. Driven by data analytics, weather, load, and market forecasts, as well as machine learning, time-based optimization, and automation, GEMS comprises a suite of 5 proprietary products that operate solely and in tandem as an energy management system. In this way, GEMS enables intelligent energy dispatch to maximize asset performance, increase sustainability, and reduce operation costs at power generation sites. Capturing over 100,000 data points per second at each site, Wärtsilä GEMS optimizes all power generation assets under one portfolio, allowing you to centrally and securely operate energy systems which may include multiple power plants, renewable, thermal, and hybrid assets. Wärtsilä's GEMS, the smart energy management system, to optimize your journey towards a 100% renewable energy future.
Ladies and gentlemen, may I have your attention, please? The webinar is about to begin. Honorable speakers, distinguished guests, ladies and gentlemen, good afternoon for those who join the webinar from Asia, especially from Indonesia. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang. First, let me introduce myself. My name is Fauzan Hanif Jufri. I am a research associate at the Electric Power and Energy Studies of Universitas Indonesia. On behalf of the Indonesian Electrical Power Society, Masyarakat Ketenaga Listrikan Indonesia, or MKI, I would like to welcome you all to the 4th episode of webinar entitled of Unlocking the New Business with Battery Energy Storage System. This webinar is supported by PT-PLN Persero and sponsored by Tide, Huawei, KEPCO, Hitachi ABB Power Grids, Siemens, ABB Sakti Industry, Trillian, GE Grid Solutions, Mitsubishi Power, Icon Plus, and in partnership with Think Smart Grids Friends and Energy Academy Indonesia, or EGAT. Today's webinar is the fourth episode of MKI Smart Grid webinar series, out of 10 episodes hosted by the Indonesian Electrical Power Society, or Masyarakat Ketenagalistrikan Indonesia, MKI, taken place from April 2021 until January 2022. Motivated by many studies confirm that providing flexible energy storage for a wide range of applications, Battery Energy Storage System, or BESS, is a turnkey solution to improve the reliability, availability, and efficiency of the power supply. Today's webinar will feature Indonesian government representative and experts from around the world to share the latest advancement and benefits of the Battery Energy Storage System, or BESS, to drive a transition towards a carbon neutral and how Indonesia play a role in this sector. Okay. Before we get started, I'd like to go over a few items so you know how to participate in today's webinar. First, the audience will have the opportunity to submit the text question to today's presenters by typing your question into Q&A box at any time during the presentation. Please mention your name and organization and to whom the questions are intended. We will collect the questions and address them during our Q&A session. And also, please note that there will be 2 Q&A sessions in this webinar. There will be a present form posted on the chat room in Zoom and live chat in YouTube. Please fill in to confirm and ensure your attendance. You will receive an electronic certificate for this webinar participation, which will be sent via email within 5 working days at the latest. The webinar presentation materials will also be sent to your email. This webinar is also live streamed via YouTube channel MKI IEPS and remains there after this event finish. Secondly, as a request from the organizing committee, we will have a photo session with all speakers. So please, all speakers, turn on your camera for a while. Maybe like for 10 seconds, we will take a picture. And I will count down 3, 2, 1 for taking a picture. Okay, I think all of the speakers are ready. Yeah, I will count down 3, 2, 1. Okay, great. Thank you. And now we would like to introduce our keynote speaker, Mr. Toto Nugroho, the President Director of Indonesia Battery Corporation, or IBC. And without further ado, I would like to welcome Mr. Toto Nugroho to deliver the keynote speech. So, Mr. Toto, the Zoom is yours, please.
Thank you, Pak Fauzan. First of all, thank you for inviting us, IBC, to this prestigious Zoom event. And I would like to convey also that we want to share some of the strategies going forward from the SOE, mainly the PLN, Pertamina Mine ID, and also from Antam, which is a shareholder of IBC, so that we can see what is the synergies and what is the future strategic development in terms of the batteries in Indonesia to support the ESS solution. So my talk will be mostly on the upstream development part, but this is a strategy that is very important to support the ESS development in Indonesia. Can we show the slide, please? Bisa tolong Mas Fauzan di slideshow?
Yeah, operator, maybe we need the presentation file of. Okay, good.
Okay, thank you very much. So let's start the presentation by next slide, please. Next slide. Okay, so I think what we also see that the growth in renewable energy increased the need for battery storage. As you can see, it is growing tremendously. I think from some of the numbers that we have on the analysis side that it is growing at a very fast number, as you can see there on the screen. And the current status is that most of them are using the lithium-ion technology batteries. It is co-located with solar generation, and currently there are over 100 plus megawatt projects under development in the current situation. And the benefit, again, of the energy storage solution, as we will know, is really a very high renewable integration. We have also the electric system flexibility, and I guess most of the panelists will be more expert on this on the next discussion. And what is needed is also the high grid reliability and resilience, and also, of course, the optimized resource utilization. Next slide. So from the I think this is a general slide where we need to see where in terms of the battery application that can be applied throughout the entire generation, transmission, and distribution. So IBC, I will tell a little bit more on IBC. We'll have some, I think, stakeholders in the generation side, transmission side, utility, and customer. But for today's discussion, I would like to have more emphasis on the development of the battery end-to-end development in Indonesia, and also especially for the ESS. Next slide. So currently what we have studied internally that there are classified into 3 categories for use case that we use. One is the utility scale for the conventional co-location, renewable co-location, frequency control, and arbitrage. So the power rating could be bigger than 5 megawatt hours, and also the capacity, as you can see, is more than 5 megawatt hours. Then there are the CNI solution and also the residential. But we will talk about more on the utility scale, which is what IBC is more focusing onwards. Next slide. And again, for the batteries in the power sector, I get, as you all know, that in terms of the power generation, grid support, availability safeguard, and then consumption optimization and e-mobility power, this is the cases that you can see the main uses. But again, these details will be probably covered by the other speakers. Next slide. Now, a little bit more now on the local demand projection in Indonesia. As you can see, we have several projections that we have internally, and also based on the government target of the usage of both ESS and EV batteries. So in terms of the total usage of, in the base case of 2035, there will be more than 30 megawatt hours of 30 gigawatt hours of demand in 2035, and mostly this is driven by the 4-wheels and 2-wheel sector. As you can see on the right side, our projection is that 600,000 passenger cars will be converting to EV, close to 1.8 to 2.5 million into the 2-wheel sector. And again, the important for today's talk is the ESS projection itself. So as you can see from onwards from 2025 to 2035 projection that we are going to have close to around 1.8 gigawatt hour of requirement in the ESS itself. Next slide. And in terms of what we have here on the ground, there are certain demand that in terms of ESS is prioritized in the power sector. So as you know, IBC is 25% owned by PLN, and we are working closely with PLN to support the needs of the ESS implementation. So there are several priority use cases. One is the TALIS, as you know, is the deployment of rural areas to increase electrification. Two, to support the intermittent power generation, which is for renewables, wind and solar, especially in remote areas, and renewable solar plus battery co-location, and the peak power provisions for peak shaving, and the provision of premium service for CNI customer. So in terms of the requirement in 2021, there will be immediate around 200 megawatt hours in 2021, and various requirement in Sulawesi and Java Bali area. And the most important thing, I think, in terms of the total installed capacity needed, this is close around to 2026 in around as previously mentioned, between 1.8 to close to 3 gigawatt hour in terms of the immediate needs in the ESS sector. Next slide. Also, in terms of battery, is the part of the solution offer for the quality solution. In terms of the number, commercial number, again, the potential there is quite a huge number, and have good opportunities for the SOE or the private sectors to have a joint, let's say, a venture on these solutions. So you can see the number that in terms of the potential market in 2025, it could reach up to 40% increase in 2025, around $402 million for the UPS kind of solution. Next slide. Another one that is also is something that we would like to point out to I think everybody here. We know that the technology improvement in the battery cells is very rapid, and in terms of the kilowatt hour production estimated price will go down to the level of close to $100 or less than $100 in 2025. Next slide. Again, and then over the next decade, we also have to, this is almost the same number we can see for the LCOE for PV and other batteries are expected to drop 4 to 5% per year. So a little bit in the more friendly glide slope here that we see, but previously for the EV batteries, the research and the I think the technology development is much more rapid, and that's why we're seeing the difference in the price drop of these two types of batteries. Next slide. Now, a little bit going into the IBC point of context, because what we see that, which is why Indonesia is very strategic in developing the ESS for the, I think not just for the Indonesian context, but also again for the demand of nickel in the world, which is going to EV and ESS battery. You can see the red column there, that it is increasing significantly, and that's why Indonesia plays a strategic role, being we have 25 or 23% of the nickel reserve in the world. So this is a very, very strategic let's say strategy for Indonesia to develop more and more on the electric vehicle and the ESS battery going forward. Next slide. Now, a little bit on IBC, because this is a new development, and this is a strategic development that we want to, of course, to share in today's webinar. Is that a little bit of introduction of IBC. IBC is a newly formed company. We are only, let's say, just 3 months old, and in terms of the shareholders, we are owned 25% by PLN, 25% by Pertamina, the Indonesian Oil and State Gas Company, 20% by MindID and Antam, who is the nickel owner or the mineral owner of Indonesia. So IBC will be formed as more of an investment holding company, where we create the end-to-end battery production from mining, and then all the way into the development of battery cells, including, of course, ESS. Again, our vision is to become the world-class global player in EV battery market. That includes the ESS also, for regionally and globally. Why we are aiming such a high aspiration is because we have two things going for Indonesia. We have, of course, the abundant resource of the upstream, and also we have the market side. In the market side, the requirement or the needs for battery EV for electric vehicles and ESS, as you can see from previous slides, is quite a huge number. So 4 things. Our main mission is to maximize the value add potential of Indonesia resources through establishing a synergized EV battery ecosystem. And the keyword here is the end-to-end development. So what we are doing currently is actually end-to-end from the mining side, smelting, precursors, cathode, battery cells, battery pack, and also recycling. We are also have to be proactively shape the Indonesian EV battery market and ecosystem, not just the battery. We are also pushing on the demand side of the pull for the market. Number 3, we like to continue to build capability. Technology, all the I guess resources to build our so, and then let's say one thing that we can be able to have to be production based hub or battery production here in Indonesia as a base of production to support. Next slide. Next slide. Yes. So this is the value chain that we are talking about. We develop all the way from the nickel side, and then of course we need to develop the smelter and the battery precursor. We call it battery chemicals and components. We have to develop also the battery cells, electricity supply, ESS, and also what is important, the recycling side on the right hand, where we process all the spent. Again, in terms of development, Antam will concentrate on the mining side, while Mine ID, Pertamina, and PLN will of course have their parts in the midstream, and especially in the downstream. PLN in terms of charging station and then supplying the electricity will be the key partners. As you know, we have consortium partner currently with the South Korean LG and the Chinese CATL to develop this end-to-end solution. Next slide, please.
Pak Toto, 2 minutes more, I think, the time.
Okay,
yeah.
Thank you. So in terms of the business development strategic pathway, what we want to do in the short term, because we have very good relationship with the number 1 and number 2 supplier of batteries, we are in the position where to find the best actual supply. But for the long term, because we will be developing the value chain all the way from upstream, then we will have competitive advantage in terms of the production costs of having the ESS produced in Indonesia. Next slide. This is, I think, my last slide that we can see for the development of batteries in Indonesia. It is not easy because in terms of the development, we need almost 3 or 4 years to develop all the chemical plants, all the aircraft, also HPAL. So we will have hopefully the target in 2024, 2025 will be our first production of EV batteries and also ESS and Indonesia. And hopefully by having this information and having this discussion with the I guess the MKI and also every stakeholders in the industry will help us to achieve this target to have the own production of battery in Indonesia and to support also the government project program for this long-term development of batteries in Indonesia. Okay, next slide. Okay, I think this is from IBC. There's something that we can share together, and then we have a more discussion. And again, it's not easy to create this solution. It is 3 or 4 years to do. And again, it will also need close to 14 to 15 billion US dollars to develop all the end-to-end solution for total capacity of 140 gigawatt hours in 2025. Thank you.
Yeah, thank you, Mr. Toto, for the interesting speech on IBC, industry development in Indonesia. As delivered by Mr. Toto, I'd like to summarize. Yeah, Mr. Toto has described the importance of the battery energy storage system, especially for power system applications. It was mentioned that the demand of the battery energy storage system in Indonesia is estimated to reach up to 29 gigawatt hour in 2035, including for power system applications and electric vehicle. And for power sector itself, the installed battery energy storage system may reach up to 3 gigawatt hour in 2026. Therefore, IBC, Indonesia Battery Corporation, as explained by Mr. Toto, has set the roadmap until 2027, which targets to have a partnership for battery manufacturing and joint studies until 2022, first battery production in 2024, and to become a regional and global battery player from 2027 onwards. Thank you once again, Pak Toto, for the interesting speech. So let's move to our next agenda, which is a presentation by Mr. Nitus from EGAT, Thailand. Again, I would like to remind the attendees have the opportunity to submit the text question to today's presenters by typing your question into Q&A box and or via live chat on YouTube at any time during the presentation. Please mention your name and organization and to whom the questions are intended. Okay, before the presentation begins, allow us to read a brief biography of Mr. Nitus. Mr. Nitus received a bachelor degree and majoring in electrical engineering. He is the director of the Generation and Transmission System Planning Division in EGAT. He takes responsibility for the supervision of several power planning works in relevant to generation system development planning, new power system development planning, transmission system security planning, as well as power system connection and cooperation planning. And without further ado, I would like to welcome Mr. Nitus to deliver the presentation on best application for grid connection and to share EGAT experience in best implementation in power system. So please, Mr. Nitus, the Zoom is yours.
Thank you very much. The organizer, could you please share my slides?
Yeah, please, the operator, the slide for Mr. Nitus. Okay, great.
Let's start at the first page. Okay. Next slide, please. Okay, thank you very much. The battery energy storage system, or BESS, are devices that enable energy from renewables, like wind and solar, to be stored and then released when the customer needs the power. Battery storage technology has a key part to play in ensuring power system can be powered by green energy or others. When there is any environment fluctuations, for example, sun is not shining or the wind has stopped blowing. Particularly during off-peak period, the IE will be started into the BESS, and then during the peak load period, the battery will be supplied to main grid via the data communications. The lithium-ion batteries are currently the dominant storage technology for large-scale plants to help electricity grids ensure a reliable supply of renewable energies. The system data such as active power, reactive power, voltage at the bus, and also the frequency of the system flow to battery management system or BMS. After that, BMS will send the set point to a value to system operator for the control the system. Next slide, please. The main function of the BESS can be categorized by three as follows. The peak shifting, use energy storage to reduce electricity demand during peak demand periods, and then recharging during low demand period. The function can be implemented by the customer or the utilities, such as the United Kingdom apply this method for the BESS function. The second is renewable firming. Use energy storage to control and track the change with intermittent wind or solar to provide a more predictable power to their power system. The last is grid. Provide backup outage, including integrate RE with distributed generation source. These methods are using in general countries around the world. The USA are also operate BESS to maintain grid reliability as well. Functions to operate because of the amount of RE and RE fluctuations. Next slide, please. This picture shows the pilot BESS project in Thailand. According to BESS benefit in above, nowadays EGAT had installed BESS in the potential RE area, which are Chai Badan and Bamnet Narong substation, located in central and northeastern area in Thailand, respectively. For the Chai Badan substation, there are many solar PV in this area. The objective of the BESS is to prevent the fluctuation in solar PV. Therefore, the 21 megawatt 1C rated of BESS is decided to install solar PV in this area. And for the Bamnet Narong substations, there is a lot of wind energy in these locations. However, the amount of RE integration is less than Chai Badan substation. Therefore, the 16 megawatt with 1C rate of BESS is installed to serve wind around these substations. EGAT expects that the advantage result of this project by three main topics. The first is strengthen the nearly transmission system. The second is support the RE integration. And the last but not least, to support the grid modernization in the future. Next slide, please. And not only this, BESS can perform many functions and we can utilize the BESS. For example, we can use for the ancillary services. The first one is backstart. BESS can service the system by avoiding fuel costs and emissions from conventional backstart generators. As system-wide outages are rare, and on-site BESS can provide additional services when no performing backstarts. And the second is often service is frequency regulations. Manage the interchange flows between control area to maintain the frequencies within the tolerance bands. The energy storage is an option for frequency regulation to maintain the system frequencies. And on your right hand side, for the utilizations, the first is a transmission and distribution upgrade deferral. Deploying the BESS can help delay the need for the new grid investment by meeting peak demand with energy storage from lower demand periods. BESS can also reduce congestions and improving overall transmission and distribution asset utilizations. The BESS can supply the solar energy during the peak demand as well. And the second is energy arbitrage. Purchase of peak electricity at low price for charging the storage system. And then the storage energy can be used or delivered at the later time when the price of the purchased electricity is high. This is sometimes referred to the electric energy time shift. Next slide, please. This is an example for investment and economics analysis. The example for investment and economic cost benefit aspect of BESS are shown. On your left hand side, the long-term investment. In the first figures, the blue line and orange line represent the investment cost for the transmission and energy storage system, as called the ESS respectively. The transmission improvement is based on load forecasting at the end of the plan. Therefore, the investments must be paid a lot of money at the first year. The result is the additional of cumulative interest. Moreover, transmission construction will face on the right-of-way problem. On the other hand, used BESS can be planted in short-term period, around 3 to 5 years, because the utility can add the sizing of BESS and the installation time is not take a long time. In addition, in case the load profile does not grow based on the load forecast, like COVID-19 situation, the utility is not necessary to purchase more battery to supply demands. According to the first graph, the space of the investment cost at the first 10 years implies that using BESS can serve the electricity free for the customer because the payment on the BESS is significantly cheaper than the transmission system. And on your right hand side, that is the picture of the net present value. Based on the right hand graph, there are 5 lines represent the number of charge and discharge of BESS called duty cycle in each year. Two continuous green and blue line, the continuous green and blue lines show the greatest and the lowest number of the duty cycle. The purpose of this graph is shown the impact between number of duty cycle and net present value at the future year. In year 2050, the top line expresses the net present value equal to past 350, while the lowest blue line display minus 95. The positive net present value means that the project is feasible and suitable for the investment. So it can imply that the more used duty cycle of the BESS is the more active to put the money in the project. However, this is the limit number of duty cycle in the practice or the practical using. Next slide, please.
Mr. Nitus, I think the time is 4 more minutes.
Okay, thank you. The challenge of the BESS are decreasing price along many years compared to the past. Based on the Bloomberg report, the BESS price is reduced over 80% from year 2019 to 2030 by decreasing from $480 to $250. The price of the ESS is in each company will be varies by the chemical substance, electrode, and also raw materials. However, in our BESS project, the BESS price is higher than Bloomberg report, above 35%, because the EPC, because of the EPC, developer overhead, and also developer margin. For the technology nowadays, only lithium-ion is deployment in the energy storage, and EGAT has also used this technology in pilot BESS projects. In the power system world, the challenge is that how the dimension and weight can reduce more than this. If it's possible, it can utilize the BESS applied to our power system, including generation and transmission and so on. Next slide, please. So this is a challenge of the flexible grid. When the battery price is low and reasonable for applying to the main grid, there are 3 ideas to conduct the BESS for flexible grid as follows. The first one is support the spinning reserve of the thermal power plant. In general, BESS can provide the speed, efficiency, and reliability as a spinning reserve to thermal power plant. It might be increase revenue by increasing power and low minimum generation level and reduce start and stop of the thermal power plant. And fast upgrade provide more service to the grid. And the second one is mobility of BESS. The movable BESS can relieve some problem in the power system. For example, a mobile BESS can mitigate the temporary power flow congestions in some area which are under transmission constructions. Next slide, please. And I would like to talk about the roadmap of BESS project in Thailand. For the roadmap of BESS project in Thailand, it can conduct as follows. The phase 1, we have a collaboration with the USAID and NREL. EGAT and USAID and NREL had a collaboration on the several study and analysis with the various stakeholders in Thailand, which focus on the capacity building for the battery energy storage system in the Thai power sector. The task will be support the EGAT by building capacity on the BESS global best practice, the method, and also the process to inform the use of BESS in the Thai power sector. Outcome of this activity may support the development of the PDP 2022. And also we analysis of the BESS application in the Satun and also the Chumphar regions, specifically exploring the opportunity for transmission deferral to inform power sector planning and operational practice. And we have in the phase 2, After implementation, the pilot BESS project, EGAT will study in 3 categories, which are electric supply time chip, and also ancillary services. And the last one is the grid system, grid transmission system support, and also the transmission congestion relief. And the phase T, the new pilot secondary source project, according to EGAT substation, is need to high reliability to supply power. So it shall be both primary and secondary source for the station service use in the substation. In primary source, EGAT use the station service in the substation. For the secondary use, EGAT may have the battery energy storage. That is an idea. The tentatively pilot substation are Krabi and Khanom substation, which will be soon. So thank you so much. That is all about the application of the BESS in Thailand and the opportunity and challenges of the BESS in Thailand. Thank you so much.
Okay, thank you, Mr. Nitus, for the presentation. I think to summarize Mr. Nitus' presentation, I point out that EGAT has initiated the pilot project in Thailand, which will be operated by December 2021, located in Chai Badan and Bamnet Narong. And also, as per Mr. Nitus' presentation, indeed the application of BESS can be economically feasible investment in the long term compared with the upgrading the transmission line. Thank you, Mr. Nitus, for sharing with us about Thailand's experience in unlocking the new business with the battery energy storage system. I would like to remind that the attendees have the opportunity to submit the text question to today's presenters by typing your question into Q&A box or via live chat on YouTube at any time during the presentation. Okay, please mention your name and organization and to whom your question are posted. Okay, let's move to our next agenda, which is a presentation from Huawei, Mr. Jingkang. But before the presentation begins, allow us to read a brief biography of Mr. Gi. Mr. Gi Jingkang got bachelor degree in telecommunication engineering from University of Liverpool, UK, and also received master degree from Nanyang Technological University, Singapore, majoring in power engineering. He takes the program on strengthening financial management capabilities in Chicago Booth Executive Education, Singapore. And Mr. Gi is the head of Smart PV at Huawei Technologies of Singapore and Indonesia. And also he has been registered as a professional engineer of the Professional Engineers Board of Singapore with PCFA level 1. To continue, I would like to welcome Mr. Gi Jingkang to deliver the presentation on Huawei Smart String-based solution. Please, Mr. Gi Jingkang, the Zoom is yours for maybe 15 minutes. Yeah.
Thank you for the introduction, and good afternoon, everyone. I am Jingkang, head of the Smart PV business for Singapore and the Indonesian markets from Huawei side. And glad to join today's session to discuss with you about the energy storage applications, which will be definitely a trend with more and more intermittent generations such as solar and the wind coming to the grid. Well, first of all, I'd like to introduce you the family of our battery storage solutions that can be used for different scenarios covering the residential, C&I utility, and off-grid. And for the residential, you can see that we have the 5 kilowatt hour, 10 kilowatt hour, and 15 kilowatt hour batteries that can be adopted at your house. And then we also come up with the iPowerQ solution, which is a very portable unit that can be used for outdoor work. In terms of some emergency situations, when it comes to the blackout, you can also use the iPowerQ to power up the key appliances. And also you can use it for drive and travel and for picnic parties as well. And over here we have the utility scale, which is 2 megawatt hour each container in a 24 container. And this is our own PCS, which actually Sorry.
excuse me, Mr. B. I think you need to slide show because it's too small. I think here.
Oh, is it?
Yeah.
I actually already shared the screen.
Yes, but it's not the slideshow mode.
Oh, okay.
Presentation mode. Yeah.
I probably stop and share again. How about now?
Yeah, it's still loading. Maybe there's a problem. The operator maybe can help. The screen sharing of Mr. G. Yeah, it's still not working. Hello, Mr. G, are you there? Hello? Yeah, I think Mr. G is disconnected. Okay, I think Mr. G has a technical issue for the connection. I think we are trying to reach Mr. G. Where is? Check. Yeah, we are still waiting for Mr. Jingkang to present the materials for the from the Huawei.
Sorry, I really apologize.
All right.
Yeah,
All right.
suddenly the Zoom. Cool,
Please
cool.
continue. Yeah. Okay.
Sorry, really apology. So,
No problem.
okay, yeah, just now I was talking utility scale, which is 2 megawatt hour each for the 24 container, and this is a PCS, which is 200 kilowatt each, and it can be mounted on a skid. You can mount 5 units, which make it a 1 megawatt on a skid. And we also have the off-grid solutions, which is iPower Cube type. It can be connected with PV and diesel generators to serve as a microgrid system. And so today I'm going to focus on the utility scale solution, which is a 2 megawatt hour each container. So as you know that for the coupling method with the PV, it has the DC coupling and the AC coupling. So for the DC coupling, the PV and the energy storage system is connected at the DC side, and then through a PCS convert to the AC, then connect to the grid side. And for the AC coupling, for the battery and the PV system is connected at the AC side. So of course, actually, when you design the energy storage system, there are a few factors to consider, including the lower capex and the higher energy throughput, the design, how to optimize the design, and in terms of the O&M, how to make it simple and easy, and also the safety and the reliability. So in the following time, I'm going to share with you the insights on these factors. Well, number one is in terms of the capex, it is not only comes from the key components such as the battery and the PCS, but also the construction cost. So the prefabricated and pre-installed design, it will bring you at least 3 benefits. So firstly, the installation is much simpler and faster. Is eliminated, And for our battery system design, it is prefabricated. So the packs, racks, and the cooling system and firefighting systems are all pre-installed in the 20-foot container. So which enables you to actually, at the site installation, it will be much faster. And secondly, in terms of the energy, we always want to improve the energy throughput in the lifespan to lower the levelized cost of system LCOS. And in a traditional design, you will see on the left is that the battery pack performances are always different, deviated from each other, because no two battery packs are exactly the same. For example, looking at here, you will see that for this battery pack, it has 16% SOC, and this battery pack has 4% SOC. So during the charging process, when this battery pack is fully charged to 100%, the charging process will stop. And then you will, if you look at this battery pack, it only charged to the 93%. So it is not fully charged. And then reversely, during the discharging process, you will see that when this battery is fully depleted, well, there are some battery packs, they are still having some energy inside. So this actually reduces the energy throughput. So this is a real case study in Anhui, China, which actually we found that during the site visit, the SOC at certain battery packs is 4%, and while actually the max pack SOC is 16%. So coming back to the design, actually, it will give you an advantage to maximize to improve the energy throughput if you have the optimizer for each battery pack. So each battery pack can function independently and are not affected by other battery packs. So for example, when during the charging process, certain of the battery packs is already fully charged, then the rest of the battery packs can still function and continue to charge similarly as the discharging process. So we adopted this design to increase the energy throughput. So this is the second aspect in terms of how to squeeze out more energy from the battery system throughout the lifespan. And the same problem happens actually when you look at the rack level. So at the rack level, the SOC can be very different as well. So this is a real site visit as well. So you will see that the SOC at certain racks is only 4%, or at SOC at certain racks is 12%. So by having such problem is actually is similar like the battery packs. So just now I described the issue encountered. So this battery rack, in terms of the charging process, it will firstly being fully charged, and this battery rack, it will be not fully charged. So to solve this problem, you will see actually when you have the rack level optimizer controller, so basically each rack can function independently and it will not be impacted by other racks. So when you have a certain battery racks have fully discharged, the rest of the battery racks can still continue to charge fully. And then next is in terms of the cooling system. So for a traditional design, in terms of the cooling system, most of the time you will see a aircon system is being deployed. So you just blow out the cold air, and then you will see that some of the battery packs or some of the racks is not having the same temperature as others. So this will result in that the temperature degradation, the degradation of the batteries will be very different. So some batteries will degrade faster than others. So this will cause a different lifespan. So this is an issue encountered. And also you will see that sometimes the PCS is inside. If the PCS is inside, it generates the heat, and while the aircon actually blows out the cold air. So in that case, the moisture might form, so which is an enemy of the battery cells and packs. So to solve this problem, actually, we've come up with the even cooling system, which at the pack level, there's a small cooling unit. And at the rack level, there's a distributed cooling system, and which is controlled by the algorithm to control the speed of the fans. If certain packs have a higher temperature, then the respective fan will spin faster to remove out the heat. And so this is a animation shows that in terms of the heat distribution, we use the even distribution cooling system to make sure the evenness of the cool air. Okay, then next is about the design for the optimal design. So traditionally, for example, if you want to have a 10 megawatt hour usable capacity at the end of the life, in the beginning, you will deploy more batteries. So to solve this problem and reduce the capex investment at the beginning, we come up with the augmentation solution, which at the very beginning, you don't need to invest so heavy and put all the battery containers. Instead, you use with the battery capacity degrades. And here is an example that for 100 megawatt hour battery, for example, at the end of the life design, based on end of life design. For the initial, the traditional method, you will actually invest at the beginning and put a lot of containers, and which might cost you 44 mil. This is a capex, and by comparing to the augmentation plans of such as adding the battery every 5 years, you will see that the total investment is dropped by 8.9%, and the optimal is that adding the is damaged the SOC of the new battery pack to the existing battery SOC. Then after that, you can slot back. So this replacement, on the one hand, is that you will need travel expense, and on the other hand, you will require additional labor as well. And also, so not only this, you need to do the balancing every 6 months, because after actually a while, the system each battery packs might have a different SOC. That's why you need the balancing. But actually, because of having the optimizer for each pack, so all these things can be avoided. So what actually you need to do, just when you reach the site, you just insert the new battery pack. Then the battery pack will do the balancing itself, because it has an optimizer for each battery pack. So which saves the expert travel and also the labor as well. And lastly is about the safety and the reliability, which is definitely one of the most important factors to consider in terms of the battery system. So over here, there are two main types of the battery technologies for the lithium-ion batteries. One is LFP and another is NCM battery. And for these two types of batteries, for the LFP, it has a relatively higher thermal runaway temperature, which is around 380 degrees. But for the NCM, the thermal runaway temperature is 180 degrees. So this is for a puncture test. You can see that once it is being punctured for the NCM battery, it quickly goes to the thermal runaway and explode. But for the LFP, only the smokes come out. And secondly, that we've deployed in terms of the battery management system, is one of the most critical things to consider, because it will prevent the system developing into failure and the critical stage. So for example, over here, the system is being monitored all the time, and once the sudden voltage change, it will cause the system to shut down. And secondly, the system, the whole the system availability. We always want to have the system to have a higher availability. But there are two things that are problems limiting the availability of the system. First is that all the battery packs stop working if one of the battery pack is failed. So once, for example, once battery this battery pack is failed, then these batteries, the rest of the batteries that are connected in the series, it will fail also. You cannot stop producing. It cannot work. But when you have the optimizers on each battery pack, even one battery pack is failed, the rest of the battery packs can still function as per normal. So this is the difference. And secondly, when you look at the PCS, normally a traditional way is you deploy a very large PCS, which is in megawatt size. But this causes a problem because once this central PCS is down, it will cause 10 plus battery racks cannot produce the power because the link is broken. So in comparison, that if you have the smaller PCS, like ours is 200 kilowatt each, so these are connected in parallel, and even one PCS is failed, you only have a 200 kilowatt out. The rest of the battery packs can still functioning through the rest of the PCS. So this guarantees a higher system availability. So these are the things that you can consider when actually when you're going to deploy a energy storage system. So lastly, I'd like to summarize all the factors. So one is pack level optimization, which gives you auto adjustment of the battery packs, so you don't need to do the self-balancing. And also the expert is not required to travel to the site to do the troubleshooting. And also it gives you a higher energy throughput. Then also we have the rack level optimization, which allows you for the augmentation plan. So in the future, you can just adding the battery containers to top up the capacity. And then also the third is about the PCS. It is suggested to use a modular design PCS because a single PCS will not affect the whole plant, the whole container output, which gives you a higher availability. And lastly is about the smart distributed air cooling system, which will actually give you a longer battery lifespan as well. Okay, that will pretty much for my part. Thanks.
All right. Thank you, Mr. Jingkang from Huawei for the interesting presentation. As explained about the technology Smart String ESS, which can reduce the levelized cost of storage by more than 10% due to lower capital expenditure CapEx, higher energy throughput, optimal design, simple O&M, and more safe and reliable. It's also a kind of modular system that provides an easy installation, easy future expansion, capable of mixing the old and new batteries with good performance. It also applies AI-aided internal short-circuit analysis, which can predict the fire hazard in advance. Interesting. Thank you, Mr. Jingkang, for the presentation. Okay, we will move to our next agenda, but I would like to remind you, if you have any question about the presentation by the presenters, you can put your question into Q&A box on Zoom or via live chat on YouTube at any time during presentation. Please mention your name and organization and to whom your question are intended. Okay, I would like to remind there will be a present form posted on the chat room. Please fill in to confirm your attendance, and the electronic certificate and the presentation material will be sent to your email within 5 working days at the latest. Okay, let's move to our next presenter from Hitachi ABB Power Grids, Mr. Rahul Mehta. Mr. Rahul Mehta is the regional head at Hitachi ABB Power Grids, Singapore. He is the technology expert and is responsible for business development of ABB Grid Edge solutions, including microgrids and BESS in Asia Pacific. He has obtained his PhD in Department of Electrical and Computer Engineering from National University of Singapore in 2018. He has been an active member of IEEE Power and Energy Society since 2013 and has more than 10 international publications in reputed journals and conferences. Without further ado, I would like to welcome Mr. Rahul Mehta to deliver the presentation with the title of The Importance of BESS in the Evolving Power System. So please, Mr. Rahul, are you ready? The Zoom is yours for 15 minutes.
Yeah, Fauzan,
yeah.
Can you hear me?
Good. Yeah, cool.
Yep.
Yeah.
Thank you. Good afternoon. I would request if you can share my slides, I think that would be easier. Is it possible? Yeah.
Yeah. Please the operator. Okay, good.
Okay, cool. Thanks. So good afternoon, everyone. I hope you all are doing good and keeping safe. Thank you for the opportunity to speak on this platform and share my insights about battery energy storage systems, not just with our customers, but also with our peers and everyone who's listening on this platform today. Can we go to the next slide, please? So in this 15 minutes, I'm actually going to touch on where battery energy storage system is today, what Indonesia is doing in that regard, and then what are the success stories that we have seen in Indonesia, and then possibly in future there will be a lot of many more of them. Yeah. So we'll talk about Indonesian power grid first, the present and the future. Then we talk about the role of battery energy storage in shaping the energy transition of the existing power grids, and then we'll talk about how the Indonesian power grid will look like in the next. I'm going to talk about a very long-term, 30 to 40 years period, and then finally we'll discuss some success stories. Yeah, can we go to the next slide, please? Yes. Okay. Thank you. So there is one more click. There's one more picture which will come. Thank you. So today, if we look at the plan of the government in Indonesia, and they have very ambitious plans that they really want to move from in terms of renewable energy, PV, wind, geothermal, hydro. If you see the chart which are given down below, and that's a very interesting trend, that if you see in 2025 and in 2050, they want to keep the oil usage as the same percentage level. There is a reduction in coal, there is a reduction in gas, but there is a jump in renewable energy, and which is where it is very reliable source, some sort of, it's like a fixed deposit where you can always either put the energy or you can take out the energy. And that is a very interesting role which battery energy storage plays. And I believe they are the only ones which are able to do it today for any grid in the world, right? So for this ambition which Indonesia is having of moving to carbon neutrality, and as everyone says, the road to carbon neutrality is electric. And that is why battery energy storage systems are going to play a key role. It was very interesting to hear from one of our speakers before that Indonesia will very soon, by 2027, be a supplier of energy storage or batteries with suppliers like CATL, LG, and that is really something which is very interesting. Today, if you see, the global demand of the batteries are massive and the supply is not as much. So if there is a country which in this part of the world is able to supply batteries to all the projects globally, that will be a very positive sign for everyone here in this region as well as in this world. Yeah, can we go to the next slide, please? Okay, so the government has their plan, and then PLN as the public utility company in the country, they have aligned their goals with what the government wants to do in terms of carbon neutrality, right? So there are they've divided into three parts. First one is renewable implementation by 2025 of 5 gigawatt. Today it is existing at 7.9 gigawatt with energy mix of 13%. And by 2025, they want to go to a percentage of 23%. So 10% increase they want to do with this plan. The other one is which is large scale hydro and geothermal potential energy. And Indonesia is very rich in having these hydro and geothermal, right? So they really have a very good strategy in increase SO2 and all those things. So that's a very interesting initiative that PLN has taken. And then the next one is, interestingly, converting all the diesel to renewable energy. So I'm sure every one of us have heard of this announcement where the government has announced that all these diesel generators, all these remote islands, which are today using 100% diesel generators, will now be using either either battery energy storage or PV or a combination of both, right? So the government has a clear plan, and so as the utility company in the country has very clear directions in where they want to go, so that they can reach their end goal of carbon neutrality. Yeah, can we go to the next slide, please? Okay, so this is something, this is a vision for the Indonesian power grid. We talk about, when we see in Europe, they have all the grids which are interconnected. And this is something I've heard a lot, not just in Indonesia, but even in Singapore, Malaysia, Thailand, that we do want to connect the Southeast Asian grids together, form a super grid, as it is called, and then also have some connection points with Australia there. So this is a very good example of how the grid will look like in future, and I hope it comes sooner than we are expecting. But when we go for such an interconnected grid, there are a few things which will really play an important role, and those things will be and that's where the green dream of the countries also come in. But we'll have a significant amount of solar, a significant amount of wind. Also the transport also has to, like today, a lot of people are already moving from conventional diesel vehicles to electric vehicles. Companies like BYD, Tesla, they are going everywhere in the region and increasing the penetration of electric vehicles into the market, right? And then the most important part will also be the communication. The more your grid becomes smart, the more you would need communication technology, so that you are every time in control, every time you are monitoring what is happening, so that you can preempt any failures which happen in the grid, and then achieve high percentage of reliability, right? So this is how I see, and I hope I can see this in my lifetime, a super power grid where all the Indonesia islands are connected, Sumatra, Java, Bali, Kalimantan, Sulawesi, and then in addition, they're also connected to countries like Malaysia, to Singapore, to Philippines, and also with Australia, right? Can we go to the next slide, please? Okay, so we talked about the dream of a country to go towards high amount of renewable penetration, right? Now, when we want to do this, there are key pillars which will allow you to do this, which will facilitate this high penetration. The first one is interconnection, right? So not every area in this in any particular country can generate a lot of renewable energy. Like for example, if you see Singapore, there's no wind here, literally zero, right? So I'm sure in Indonesia also there will be some part of the country where you can have more solar, but in the other parts you cannot have that excess solar energy, right? So what you would need is an interconnected grid where you are able to supply the excess energy generated on one side to where there is excess demand, right? So that is really very important. Otherwise, curtailing the renewable energy sources is not going to solve anyone's problem, right? So we can manage the supply by interconnecting the grid. The second one is demand management, right? Typically, what happens is the supply always follows the demand, right? But as we move towards renewable energy, what we would need to do is we would need to match the supply, and that is where we would need a flexible demand. So we have managed supply, we have managed demand, and then what can do both of these things, and that is energy storage. And that's the beauty of it, that it is able to act as a load, it is able to act as a generator whenever it is needed, right? So for any country to increase the penetration of renewable, what you would need is flexible demand, flexible supply, and then on top of it, energy storage, right? Which can do both. Can we go to the next slide? Okay, so now we have come to a point where we have a grid, it can be interconnected, it has a lot of renewable energy, like solar or wind or geothermal or XYZ, could be anything, right? But now when we have such a grid, what do we need to operate a stable and secure grid in today's environment, or let's say after 10, 20 years, right? So there are 4 key parameters that we see, which are very key for operating any grid in any part of the world, right? The upper 2 parameters which are there, the functions are inertia and system strength, right? Today, typically or traditionally, these 2 functions, inertia and system strength, they are being provided by synchronous generators, these large rotating machines which are acting very fast. So it is faster than your fast frequency response. So these are inherent features of a synchronous generator machine, so that whenever it detects any change in the rate of change of frequency, it immediately starts either injecting power or absorbing power. Now, this is the function which is performed by a synchronous generator today. Now, what happens when you install solar? You are losing all those synchronous generators because solar does not rotate, right? To solve this problem, there is battery energy storage for your help, right? So battery energy storage are capable of operating as a virtual synchronous machine, or there is another term for it. They are not any energy storage system. We call them the grid forming battery energy storage systems, which are able to protect your grid against such disturbance. Now, this is something which is going to come in the next 4-5 years, where all the countries in this region, I'm talking about Indonesia, Philippines, Thailand, and all these places where you will see massive adoption of PV. And that's where you will need to have battery energy storage, the grid forming battery energy storage, to provide this system strength as well as inertial response, right? The one functions which are down below, frequency control and voltage control, they are your secondary response, right? So they are your second line of defense, which is where they are supporting the grid by providing any changes in the frequency and voltage are the batteries are charging and discharging accordingly. So this is where, and as you can see, batteries are performing all these 4 functions, and they are the first line of defense as well as the second line of defense. Right. Can we go to the next slide, please?
Mr. Mehta?
Yeah.
I think the time is 3 more minutes, I guess. Yeah.
Okay, sure. So in this slide, I just want to focus that if you see the lowest levelized cost in 2020, and I'm only talking about 2 ESS technologies, lithium ion, which is what we are going to use today, which is what we are going to use maybe for the next 5 to 10 years. And then gradually there will be a shift from lithium ion to hydrogen, right? And that is what this picture is also showing. So if you'll see lowest levelized cost in 2040, there is a significant portion of batteries, and then up there, this gray portion is indicating hydrogen. Yeah, can we go to the next slide, please? Okay, this is a lot of my colleagues have discussed about the various functions of energy storage. So I will not go in details, but some of the things I really want to highlight here is today, battery energy storage is needed by utilities who are doing generation, independent power producers, the renewable power developers. Plus, they are also needed by the utility companies for supporting their grid, supporting their system operations, supporting any form of investment deferral for grid reinforcement by providing grid ancillary services. And then there are industries. Now, if industries are also the private industries, big players having big cogeneration plants, they are also looking at energy storage for network stability, for reactive power support, for even peak shaving, right? So, and then the last one, other than industries, is transportation. We don't see much usage of BESS per se, not the batteries, BESS per se in the transportation sector yet, but this is something which will be coming in the next 10 to 20 years. Yeah. Can we go to the next slide, please? Okay, so this is based on our experience, what we have seen in Indonesia. There are various regions. If you look at Kalimantan, if you look at Sulawesi, and if you look at Java Bali grid, these are the 3 place of, okay, let me redistinguish them. So Kalimantan and Sulawesi are these two places where industrial usage of battery energy storage is a lot, right? And then on the other hand, if we look at Java, Bali, Sumatra, Kalimantan, and Sulawesi, that's where utility scale battery energy storage systems are coming in. They will come a lot in the future, and the applications are all which are discussed, right? The main goal is to provide stability to the grid and to operate a secure grid. Can I go to the next slide, please? Okay, so this is my last slide. Some happy and interesting project references that are there in Indonesia already operating. I want to focus on the first two, which are already installed and are in operation. So the Bontang PV hybrid, it's a system in East Kalimantan, 2 megawatt hour energy storage system with 3 megawatt PV. And this is the largest hybrid microgrid in Indonesia today running successfully, right? The first one is a PLN system, Semau PV hybrid. It is part of the remote electrification initiative of the government, and we are very happy to be part of it. The third one is an ongoing project which we are doing, and we are actively looking to make Indonesia more green and more sustainable as it is today. Thank you. That's all.
Okay, thank you, Mr. Rahul Mehta of Hitachi ABB Power Grids Singapore for the interesting presentation. Mr. Mehta highlighted that the key enabler for the massive implementation of variable renewable energy sources is the application of the battery energy storage system. One of the reasons is the ability of the BESS to provide inertia or grid forming services, frequency control, as well as the voltage support to the electrical power system. He also pointed out some of the PV hybrid system project in Indonesia, very interesting, such as in Semau, Bontang, and also Selayar. Yeah. Thank you, Rahul, for the presentation. And also thank you, Hitachi ABB, for always supporting Indonesia in the power sector development.
Thank you.
Okay, next, we will have the first session of Q&A. We are now going to take some of the questions from the Q&A box on Zoom and from the live chat on YouTube. We invite Mr. Toto, if you are still with us, Pak Toto.
Yes, Pak.
Yeah, Mr. Nitus from EGAT, Mr. Jingkang from Huawei, and Mr. Rahul Mehta from Hitachi ABB. Okay. All right. I can see Mr. Nitus, Mr. G, Mr. Rahul. Pak Toto masih belum ini. Oke, sudah. Okay. Just for a reminder that all webinar participants can still submit the question through the Q&A box and or via live chat on YouTube. Okay, so our first question is for Mr. Toto, the President Director of IBC. Yeah. Actually, I have 3 questions now in my hand, but I think this is just like a short answer because asking about the IBC. First one is posted by Ahmad Amiruddin, asking what type of lithium-ion battery would be produced by IBC, and how IBC will compete with the existing player. That's the first question for Mr. Toto.
Okay.
And I think I will read the second question first, posted by Waluyo Nugroho, asking what is IBC contribution to the national BESS requirement? Maybe it's kind of percentage to the national requirement. And the last one is by Johnny Tam, asking when will IBC be ready or able to deliver and support the BESS requirement in Indonesia? I think that's all the question for Mr. Toto. Please, Ms. Toto. Yeah.
Okay, thank you. I think I'll address the first question first regarding what is the battery chemistry that we will develop. Currently, as you know, we are working with two of the biggest partners in terms of the battery EV production for EV and BSS also. And actually, most of these players are looking at the NCM type of chemistry. So nickel, cobalt, and manganese. And I guess there will be some kind of maybe technology differences between these two companies. But basically, they are using the NCM technology and not the LFP technology. So that's my first answer. In terms of competing with the existing player, again, that currently Indonesia or production in battery, Indonesia has the advantage of having direct access to the mineral that we have here in Indonesia. And that is a significant cost difference where we have the actual mining operation, we have the actual smelting, HPAL production, all the way into the battery production. So in terms of the kind of competitive advantage that we have right now is, of course, the cost that is producing these batteries. So with our current prediction, we will have better than more than about 12 to 14% in terms of cost advantage over production, which is out of Indonesia. So that's one thing that is making us competitive, because we have here the resources in Indonesia. We have here the production of batteries here in Indonesia, and also we have the market here in Indonesia. Some of the batteries will be exported, of course, but when we did the calculation, these batteries will still be competitive given the, let's say, target areas of Europe, China, and the US. So we have done this calculation, and we still have competitive advantage for the batteries which are produced in Indonesia. Second, from Waluyo, in terms of the IBC market for the ESS, this is a short-term kind of entry for IBC going into the ESS business here in Indonesia. So as you know, we are currently in the negotiation, or also early talking with the PLN directly in terms of how can we support PLN in implementing the ESS solution. So I will not go into how many percent that we can have, but I think if we have, I think just a minority part of the supply to the PLN would be good enough for IBC. And can you repeat the second question from Pak Waluyo?
Sorry. Pak Waluyo asking only about the national contribution of IBC contribution to the national requirement of BESS.
Yeah. As I said before, because it's a 3 gigawatt projection, and I think if you have some kind of minority kind of contribution in terms of the supply side on the early stage, let's say for when we don't have production, then we can have a minority involvement in terms of supplying to PLN. But once we have production here in Indonesia, of course, then it will be a very big contribution in terms of percentage that can go in supporting the PLN in terms of the ESS needs in Indonesia. Thank you.
Maybe the third question is from Johnny Tam, Pak Toto. Yeah, the question is, when will IBC be able or ready to deliver and support the, I think, BESS in Indonesia? Yeah.
Okay, so I guess in terms of timeline, to support the immediate needs of PLN in Q1 2022, I think we will have some kind of arrangement with PLN to supply, as I said, a minority part in terms of the percentage of the requirement. But then after that, we will scale up, of course, once we have production, especially after 2025, that is the point where we can have our own production. And this is a very strategic kind of development where we can produce our ESS batteries here in Indonesia and then supply this to the requirement of domestic needs in Indonesia.
Yeah. Okay. Thank you for the response, Pak Toto. Really appreciate it. We wish IBC becomes a leader in the battery business in the future.
Thank you. Thank you.
Now we can go to the another question from Pak Hari Tambunan. Yeah, this is for Mr. Nitus of EGAT. Yeah, from Hari Tambunan. The question is, could you explain what is the parameter assumption or the main criteria that BESS is cheaper than transmission in the long term in terms of investment and economic? Because the transmission asset can be more than 20 to 40 years lifetime. Yeah. That's the question for Mr. Nitus. Please, Mr. Nitus.
Thank you very much for the very good questions. Yes, you are true. The transmission system have a very long life compared to the battery energy storage system. I would say that we cannot compare like apple to apple for the transmission system and the energy storage system. We have the same situation during the evaluation of the project. When we compare between the two projects, that is the new transmission system and also compared to the energy storage system, which one should be built? In near future, we found that energy storage system cannot win in many situations during the evaluation of the projects. However, the energy storage system have the good functions that can perform. For example, we can utilize the energy storage system for the ancillary services such as frequency control, and in some case like in the research about the increase the moment of inertia of the power system to maintain the frequency stabilities. When we integrate the renewable energy into system more and more, that will impact to the inertia of the system. And not only the energy shifting, that is the main function of the battery storage. So in brief, if we would compare between two projects, we should add the benefits of the energy storage, that is the utilization benefit, the benefit from the utilization to the project for the comparison too. It's, with this way, the battery energy storage can more economics by this context.
Yeah. All right. Thank you. Yeah. Thank you for the answer, Mr. Nitus. It is clear that we cannot compare just like apple to apple. That we have to consider also the benefits brought by the BESS compared to the transmission line. Okay. Thank you, Mr. Nitus, for the answer. The next question is from Vidya Prabawa. For this one is for Mr. Rahul of Hitachi ABB. The question is, Mr. Rahul, it is interesting that one of your project is a hybrid between solar PV and CFPP, I think coal-fired power plant. Yeah. What is the most difficult technical challenge on implementing this hybrid system? Is the CFPP ramp up and ramp down could be assisted by the battery energy storage seamlessly? Thank you. Yeah.
Okay, thank you for the question. So first thing which is important is, and this is relevant to any project, is defining the operational philosophy on what the customer is looking at. Right? When you're already having a coal-fired power plant, you want to install a solar there, you want to store install a battery energy storage there. The biggest challenge that we have faced in our projects is the customer sometimes says that this is my applications which I need, but by the time the project is done, there are always changes in how the operational philosophy is to be defined. So I would say that was the biggest technical challenge which we have faced in our projects, where the applications changes during the duration of the project. Now the other thing which comes in is the integration, right? So there is a control system which is already working on the CFPP side, which performs the ramp up and ramp down, right? So when we provide our eMesh control system, we do provide an interface which goes for not just the batteries plus solar, but it also interacts with CFPP so that it can perform this seamless transition and a seamless the ramp up and ramp down, right? And when I say, I'm sure everyone knows here that batteries they really don't have any response time, right? They are as quick as it can be. Right, so they work in the control system is in such a way that it brings in all the assets together. It responds to the system together, and then accordingly, whatever the functions are coming in, whether it is for frequency, whether it is for voltage, whether it is for smoothing the PV power, everything is done by the control system. So that's where a lot of people say that this is the brain of the system, and it really is. It really does this part.
Yeah. Thank you, Mr. Rahul. I think it is quite clear. Yeah, we know that battery can respond instantly, instantly. So the hybrid system will be depending on the EMS, energy management system. Okay. I think this is the last question for this session. For this one is for Mr. Jingkang of Huawei. Yeah, in your presentation, it is mentioned the term of smart string ESS, yeah, BESS. As I understood that it is referred to a pack level as well as a rack level optimization that Huawei proposed, which is claimed to increase the lifespan discharging energy by 6 to 7%. Could you please elaborate a bit more about the optimizer? Is it on the BMS, battery management system level, or PCS, maybe conversion system, or what? And also, does it mean that to apply such optimizer, it must use the Huawei battery product, or we can use any battery type, and Huawei can provide the optimizer or controller? Thank you.
A good question. Thanks. So basically, the optimizer is already in the Huawei battery pack. So it is a hardware that has been already installed in the battery pack. So basically, we do not sell this optimizer in the market independently. So it has to work with our battery in order to achieve the pack level optimization. And similarly as the rack level optimization, there's a rack level optimizer which is being installed in the system already. So it's only compatible with our Huawei system. Yeah, and then sorry, the second question is regarding to.
Yeah, I think the one question here mentioned. Can we use the other battery other than the Huawei product?
So yeah, just now I mentioned, yeah, you cannot use the other battery.
Okay.
Yeah, only our and it is actually a hardware inside the system, not only the software. Yeah.
All right, I see. Yeah, thank you, Mr. Jingkang, for the answer. Yeah, as informed by organizing committee, we still have time. I think we will have one last question for all presenters here for Mr. Nitus, Mr. Gui, and Mr. Rahul. I think it's quite from the question is from Halason. Yeah, from Halason. The question is, first one is how do we increase the maybe capacity of battery storage? How do we increase? That's the question. And how is the energy storage useful on a grid scale in combining combining with the fuel generation sources? Yeah, I think that's a question I got from the Q&A box. I'll try to understand this one. The first one is, how can we increase the capacity of the energy storage? Yeah, maybe in terms of, I don't know, in the future, or if you have the degraded efficiency or whatever, how can we increase the capacity of energy storage, battery storage? And how can the energy storage combine with the maybe fossil fuel power plant. How can they be combined? Maybe in terms of operation, something like that. Yeah. Maybe the first one I'd like to hear from Mr. Nitus. Please.
How to increase? I think that should ask the supplier like Huawei or.
All right.
But for the second question, I would love to answer. But okay, we will start with the first question first.
Okay, sure. Yeah, how about Mr. G and Mr. Rahul? Maybe Mr. G first about the first question about can we increase the capacity, maybe degraded efficiency in the future or whatever? How can we do that?
Yeah, in terms of the capacity, sometimes it is also limited by the battery or cell technology. But actually, in terms of the design, for example, you can see that sometimes different suppliers, you might have different size in a 20-foot container. So imagine the footprint is a 20-foot container. So whether how much megawatt hour you can put inside is from the design side, also from the battery or cell technology side. So in terms of actually the usable capacity, is that how you can manage the system better so that can improve the round trip efficiency, and also like how you can get to the higher energy throughput in the lifespan. So these are the things that can be considered when you actually we are going to develop the solar and solar plus energy storage system project, for example. Yeah, for the ESS, basically this is my reply to the question about.
Yeah. How about Mr. Rahul for the questions?
Okay, so I'm increasing the battery storage. If you just want to expand it, can you hear me?
Yeah, I hear.
Okay. Now, this is okay. Very open question. I want to answer it in two ways, right? Like, increasing the size of the battery storage. There is a reason for it. Why do you want to expand the battery energy storage? Maybe you find more applications, or maybe the existing system is not enough. So then you can always make provision. Like I think one of my fellow speakers, he did present on various schemes. There is a scheme where you go for initial augmentation. You put all the capex in the beginning of the project, and then the other way is to do the capacity augmentation plans during the course of let's say after 5 years, or there are even some schemes in which you are augmenting every second year, right? But the main idea here is, why are we increasing it? Number one, do we have enough space to increase it? And then the third and the most important point is, when we are putting batteries on the side, we always have to make sure that there are enough connection points available, right? Because you put the batteries, you still have to connect them to the medium voltage or wherever it goes, right? So that part has to always, you have to make sure that you have made those provisions before you can think of any expansion or augmentation of your initial energy storage.
Yeah, I agree that I think it should be based on the design, right? Our planning and design for the capacity of battery energy storage. All right. I think due to the limited time we have for this Q&A session, some of the questions cannot be addressed, and if you can possibly ask through the Q&A, and we can try to compile and find the response from the presenter. Okay, thank you all of the presenter, Mr. Nitus of EGAT, Mr. Jingkang from Huawei Technologies, and Mr. Rahul Mehta from the Hitachi ABB, and also our keynote speaker, Pak Toto Nugroho, the President Director of IBC. Thank you for the presentation and sharing in this first session of our webinar. We will have now a break for 15 to 20 minutes to enjoy our sponsor videos, and I will be back immediately afterwards. Okay, enjoy.
Thank you very much.
Thank you very much.
Thank you.
Tide strongly believes the importance of environment protection and energy efficiency in order to achieve a sustainable future for mankind. Thus, our technological commitment will foster mutual betterment of our allied companies, customers, shareholders, and employees. Tide pledges to always hold our management philosophy and values at heart. Until now, the meter readers have had to do manual meter reading. This existing manual process is time and money-consuming work. This makes it hard for us to detect blackout and manage energy demands. And it makes us hard to manage loss during transmission and distribution. As a result, this existing manual process makes grid unsmarter. But Tide's end-to-end AMI solutions will connect the user with utility companies. Tide's intelligent AMI solutions will solve many problems from the existing manual process. We can reduce time and money spent metering manually. We can manage blackout and loss during distribution. We can do demand response, TOU. Finally, we can make grid smarter. AMI service. Meter reading information of household is call-seated by modem and DCU. There are two types of smart meter, internal and external. Smart meter sends metering data to modem via serial communication. Modem sends metering data to DCU via PLC communication. DCU sends metering data to server via fiber optic and cellular network. On-time monitoring and detection of electrical loss. TOU, time of USC flexible tariffs. Connectivity to electric vehicle charging system. Connection of renewable energy and battery with bidirectional metering. Reliable collection rate improving, monitoring of power quality. Making grid smarter and more efficient. A hidden champion in the energy IoT solution industry. Tide.
It's easy to be blinded by the urgent issues facing our planet. But to shut our eyes is not in our DNA. We look at problems not as one big challenge. We break them down into a spectrum of solutions. Leveraging our pioneering and digital technologies to co-create innovative solutions with our partners and customers across the entire value chain. Powering efficiency by creating a smarter, more flexible power grid. Powering resilience and reliability by digitalizing the energy value chain. Powering safety by enabling cyber-secure infrastructure for mission-critical sectors. Powering sustainability by integrating renewables into the power grid. We are two pioneers combining generations of expertise for a stronger, smarter, and greener future. Powering good for sustainable energy. Hitachi ABB Power Grids.
Power has changed everything. The progress of people depends on it. But this has impacted our planet too. Where do we go from here? Do we restrict energy to protect our environment? Or do we keep using energy to drive our progress? How do we solve this? We need more options than we have today to solve the challenges we face. Because the right answer isn't a single answer, and it isn't a simple answer. At Mitsubishi Power, we are imagining new possibilities. We are constantly innovating new technologies to make the energy we need to thrive not only better than ever before, but different. Our energy solutions are as diverse as the communities we serve. For more than 100 years, we have applied innovative engineering to bring power to people everywhere. Today, we partner with our customers in every community as they build their paths to reliable, affordable, and decarbonized power to make a cleaner and happier world. At Mitsubishi Power, we are creating a future that works for people and the planet.
E is the beginning of change. E is a mission for the planet Earth, not just a new business. E is the power for a sustainable tomorrow, not just a source of power. E is a challenge for a better future, not just about adapting to survive. E is an innovation that turns imagination into reality, not just an everyday thing. Far beyond the great history we have made, becoming a global leader in smart energy. We are reborn anew. LS Electric.
If you're following the worldwide increase of clean energy sources, you may have discovered increased buzz around energy storage and renewable energy. What you might not know is that energy producers rely on sophisticated energy management platforms when integrating these innovative energy options into their existing power systems. Take Wärtsilä's energy management system, GEMS. Combining multiple data sources, GEMS uses algorithms and machine learning to automate decision-making for power producers. It ensures the energy system performance is always optimized, no matter how many renewable and traditional energy sources GEMS combines. Wärtsilä GEMS has been refined to build, monitor, and intelligently operate power plants and energy resources. GEMS has become the leading smart energy management software that benefits energy producers in their daily operations. Driven by data analytics, weather, load, and market forecasts, as well as machine learning, time-based optimization, and automation, GEMS comprises a suite of 5 proprietary products that operate solely and in tandem as an energy management system. In this way, GEMS enables intelligent energy dispatch to maximize asset performance, increase sustainability, and reduce operation costs at power generation sites. Capturing over 100,000 data points per second at each site, Wärtsilä GEMS optimizes all power generation assets under one portfolio, allowing you to centrally and securely operate energy systems which may include multiple power plants, renewable, thermal, and hybrid assets. Wärtsilä's GEMS, the smart energy management system, to optimize your journey towards a 100% renewable energy future.
Okay, welcome back to the 4th episode of MKI Smart Grid webinar series. Today's webinar is talking about the unlocking the new business with battery energy storage system. I would like to remind that the audience, the attendees, have the opportunity to submit the questions to today's presenters by typing your question into Q&A box on Zoom or via live chat on YouTube at any time during the presentation. Please mention your name and organization and to whom your question are posted. We will then collect the question and address them during our Q&A session after all the presenters present. So let's move to our next agenda. The next presentation is from Wärtsilä, which will be presented by Pak Febron Siregar, and we'll talk about battery energy storage solutions. Pak Febron was born in Medan, Indonesia, and he received master degree in 1995 in marine technology at Delft University of Technology, the Netherlands. And in 2000, he received a master degree in engineering management at Curtin University of Technology, Perth, Australia. His journey began as a software development engineer at Maritime Research Institute in Netherlands on June 1991. He is currently the sales director in energy business at PT Wärtsilä Indonesia. Pak Febron, please welcome, and Zoom is yours for 15 minutes. Thank you.
Thank you, Pak Fauzan, as our moderator. Let me share my presentation. Let me know if you can see my presentation.
Yeah, that's great. Okay, now the slideshow is okay. Yeah.
Okay, thank you, and good afternoon, ladies and gentlemen who attend this Zoom webinar from MKI. And I would like also to thank MKI to give the opportunity to Wärtsilä as a speaker. And in this opportunity, I will talk about battery energy storage solution from Wärtsilä. Before I go to the battery energy solution from Wärtsilä, I would like to introduce Wärtsilä itself to whom may not know Wärtsilä yet, because there is some saying in Indonesia, tak kenal maka tak sayang, or do not know, then do not love. Wärtsilä is a company from Finland, founded in 1834, and is a global leader both in marine and energy market. But today I will focus in energy business. Wärtsilä globally has around 5 billion euro sales last year, and located around 200 locations in the world with 19,000 employees, which is in consists of 140 different nationalities. Wärtsilä create optimal paths toward 100% renewable energy system by providing all the essential technology, solution, and value-adding services for sustainable and reliable power systems. The energy market landscape is in transition and is moving towards more flexible energy system with rapidly increasing share of renewable energy and wider application of storage technology, resulting in a decrease of inflexible base generation. The declining cost of renewables has begun to reduce new investment in coal and other inflexible baseload technology. This transition will eventually enable renewables to become the new baseload, which will require flexibility and storage to ensure reliable power generation. Our solutions are at the very core of future energy systems. We understand the role that different technology play in our customer power systems and enhance the asset of the customer through software, EPC offering, and global service capabilities. What is Wärtsila's solution to support the current energy transition? First is flexible power plants. Flexible power plants are tailored according to the specific requirements of our customers, utilizing modular future-proof technology and services. They provide the best means of support to the power system by offering the highest degree of flexibility, enabling major savings, and creating an optimized response to rapid change in intermittent generation. Secondly, energy storage and optimization. Tailored energy storage solution that build a resilient and intelligent power system, unlocking the way to an optimized renewable energy future. Regardless of what asset of our customer have, we can optimize their power system. We optimize the output of flexible power plants, renewable energy resources, and energy storage system to minimize costs, reduce carbon footprint, and ensure grid reliability. Last but not the least is our lifecycle services. Wärtsilä provides a broad range of lifecycle solutions, products, and services that enhance lifecycle business performance of power generation companies. Lifecycle solutions encompass performance and maintenance management, as well as operational expertise, leading to safe, reliable, and environmentally sustainable operation. Our solutions are based on latest digital technology, such as advanced data analytics, artificial intelligence, and machine learning, combined with our vast knowledge and expertise of power generation. Wärtsilä energy storage expertise consists of full EPC capability, GEMS software. GEMS is a Gridsmith Energy Management System, or Wärtsilä GEMS software, O&M based in region, and also optimized of technology mix for best total cost of ownership, and proven global energy industry expertise. This last about proven global energy industry, I will show to the next slide. Here you can see that Wärtsilä global project now is over 1.5 gigawatt are in operation, deployed, or contracted. This consists of in America region, Africa, Europe region, and also Middle East Asia region. Our GEMS is the leading energy management system. Maybe you can see also from our video. So the GEMS inputs can be coming from all the asset, whether it's from batteries. Actually, we have two types of batteries. We call it GridSolve Max and GridSolve Quantum. I will talk more about that later. And also about thermal, renewable, can be solar, wind, or other means of renewable. And this as input to GEMS operating system or control layer, which consists of fleet director, power plant controller, grid controller, analyzer, and IntelliBidder. And this gives to the solution for the storage plus, renewable plus, island grid or microgrid and engine. This actually can support all the market application, as already mentioned by previous speaker, such as Nitus for EGAT, and also Mr. Rahul Mehta from Hitachi ABB, that this market application of BESS or using the energy management machine can support the frequency response, microgrids, auxiliary services, grid reliability, energy arbitrage, and auto bidding. I think this is maybe not really applicable in the regulator electricity market, but such as in US, auto bidding is really really good tools for IPP or to get the best price at the best moment. As I mentioned earlier, Wärtsilä battery energy storage system solution. Actually, we recently launched a new type. We call it GridSolve Quantum. It will be a next generation platform for us. It is really compact. One unit can produce up to more than 1.4 megawatt hour. And the weight is quite less. It's only 14 ton. Compare, I think previously Nitus is around 30 ton. So this is really easy to transport and also to install. I will talk more also on the next slide. And the specific of this, I think that quantum interconnection concept. This is like plug and play. So when installation, you just connect the interconnection bus, and this interconnection bus actually consists of the DC bus, AC auxiliary, and also the communication bus. So this is already embedded, so no need for cabling anymore, just plug and play. So this is about the technical specification. I don't think I should go on detail, but you can see that this GridSolve Quantum can be put up to 9 units in a row, which can goes to 13.4 megawatt hour. So they have single point of interface for side wiring because the rest is already interconnected. And what is the advantage of this GridSolve Quantum? Why Wärtsilä developed this new battery energy storage solution? This based on the following criteria, that this quantum should have a lowest life cycle and total cost of ownership, smallest system footprint and flexibility, shorter overall delivery time, as I already mentioned earlier, is easy to transport, and also minimize scope and complexity of EPC, so the installation time, site activity can be reduced significantly. And Wärtsilä, as a power generation player quite some time, safety is really important to Wärtsilä. So our quantum was designed to meet North American and international safety standard. And this include fire detection, electricity safety, emergency stop, fire suppression, monitoring and control, and risk mitigation. So here you can see that it's really simple and simplified, the scalability and easy deployment. So no need for reefer container, and also actually the cooling system already installed, and I talk more about it. Here you can see is a GridSolve Max in Singapore. There is Singapore government. I think they want to have 300 megawatt hour battery, but they put several BESS provider to compete in 2 years. And after 2 years, who is the best performance, then we'll get the 300 megawatt hour project. And this is a picture of GridSolve Max, our previous before GridSolve Quantum. So here is about GridSolve Max battery. It is 40-foot container. I think for us is already quite. We develop a new battery energy storage system. And here you can see the difference. As you see that the cooling system, GridSolve Max is still using air cooling. I think that maybe the other also using air cooling, but our new GridSolve Quantum is now using liquid cooling. I think that is based on our research and development is much better than air cooling. And we are not a battery manufacturer, so we are neutral to battery. So we can use CATL, and actually we are looking forward for the battery from IBC, from Pak Toto Nugroho, because he mentioned earlier that he will also have a cooperation with CATL, and Wärtsilä use CATL quite a lot. So hopefully that later after IBC can produce the battery, we can use also in our battery energy storage system, so that the local content of battery energy storage system can be increased. So the GridSolve Quantum development is give improvement on enclosure costs, reduction on installation costs, faster production, and smaller system footprint, which all in all give around 12 to 15% reduction in total cost of ownerships. So this is about the inside of the GridSolve Quantum block components. I don't have to go in details. Now this is interesting. This is the GridSolve Quantum modular, scalable, and really safe. So here you can see around 222 megawatt hour site. So the height is around 58 meter and 51 meter height. So I think less than 3 hectares for a 220 megawatt hour site. So all in all already included. So of course, maximize tech revenue opportunity is the cost benefit of managerial battery cycle. And as we know, battery warranty are quite complex because it depend on several values, as mentioned here. And this value is not tracked by the BMS or battery management system, but our GEMS can track all this value and provide trend analytics for ongoing plan optimization. And as we know, renewable energy is quite with high volatility, especially wind turbine or even the solar PV. So battery system sizing is really depend on the operating profile of renewable energy asset or the load data. I think 1 year is 1 year data will be preferred. And the warranty, as I mentioned, is quite complex and usually depend on the how use case of battery, and also what is the guarantees based on energy throughput per annum. And so far, I think the battery OEM can provide 15 years software warranty based on operational profile. And as Wärtsilä, we are happy to simulate use case for system realization.
Febron?
Yes.
The time is 2 minutes more.
Yeah, I will wrap up. Thank you. This highlight all of the battery, and this what's the life cycle cost for the battery energy storage from the base until the complete, we call it gap. And I just give the case study, island microgrids. We have two. One is in Azores, Portugal, that the asset is solar PV, wind power, and Caterpillar diesel. And with GEMS, the LCOE, you can see from the graph, can be reduced significantly, that 70,000 liters of diesel per month can be eliminated. And the second case study is Bonaire, and there is 5 FMO engines, 6 megawatt hours energy storage, and 13 wind turbines. And this wind turbine can be increased the penetration from 20 to 33%. And by that, decreasing the 5% HFO and CO2 emission. This is some recent development of our battery storage system. Casio market 70 megawatt in US, Southeast Asia 200 megawatt actually in Philippines. Graciosa, as also mentioned as the case study. PGM market in US, and Pivot Power is in UK. Actually, this Pivot Power interesting because this is to charge the EV. Actually, the battery energy storage support to charging the EV, electrical vehicle, and the Bonaire. Let's conclude my presentation. Thank you.
Yeah, thank you, Mr. Febron Siregar, for the interesting presentation, which Pak Febron have shared Wärtsilä experience for supporting the energy transition worldwide, as well as some of the BESS application for wide range solutions. Some of the Wärtsilä products include the GEMS, kind of energy management system, and BESS called GridSolve Max and GridSolve Quantum. Also interesting, Pak Febron pointed out some of the island microgrids that can maximize the renewable energy penetration with the help of the BESS. One location in Portugal, I see, even can boost the renewable energy from 15% to 65%. Very interesting. Thank you, Pak Febron, for sharing with us.
Thank you, Pak Fauzan.
Again, as a reminder, the participants can have the opportunity to submit their question to today's presenter by typing your question into Q&A box on Zoom or via live chat on YouTube at any time during presentation. Don't forget to mention your name and organization and to whom your question is intended. We will collect and address the question during our Q&A session. Now we move to our next presenter, which is from Mitsubishi Heavy Industries Indonesia, which will be presented by Mr. Ahmad Hikam with the title of the presentation of Best Technology and System. Mr. Ahmad Hikam received bachelor degree from Tokyo Institute of Technology in Mechanical Engineering and also master degree from Tokyo Institute of Technology in Mechanical Engineering. His career began at Chiyoda Corporation in piping material engineer on 2007. Now he is the senior manager, head of business development at the PT Mitsubishi Heavy Industries Indonesia. Pak Ahmad.
Okay, thank you.
Yeah, are you ready? The Zoom is yours for 15 minutes, please.
Okay. Can you see my screen?
Yeah, it's clear.
Okay. First of all, thank you very much, Pak Fauzan, for the introduction and also for the opportunity to be speaker in this very good webinar session. Okay, so before I go to the main topics, kindly let me introduce MHI Group. So MHI Group is a global engineering and manufacturing company with a wide range of the business field in here, from the energy system, and including the nuclear, plants and infrastructure, logistic and thermal, various machinery systems, and also including the defense space system and also aviation system. For today topics about BESS, exactly that one is including in the energy system, and Mitsubishi Power is our group that handle that kind of the business. This one I show you the achievement of our group in Indonesia. The first of all, the major one is power plant, and this one is also handled by Mitsubishi Power. And then there's a chemical and fertilizer plant. We already built like 8 chemical and physical plants around Indonesia. And we also have the achievement in transportation around Jakarta, and also industrial equipment, which covering from the genset, air conditioning system, chiller, forklift, and various machineries for various industries. And speaking about the power plant, here is some summary of our achievement to providing the gas turbine for the power plant in Indonesia. If you calculate all the power plant in here, this is already 60% of total installed capacity in Indonesia for the power plant. And not showing in here in this presentation, but Mitsubishi Power also supply the turbines and also boilers for other industrial fields like pulp and peppers and cements and etc. Okay. In here, Mitsubishi Power is also supporting the technology development in Indonesia. And one of the activities is conducting the research with ITB, Bandung Institute of Technology, in various subjects related to the smart grid application in Indonesia. In here, we would like to stress about the carbon neutral, which lately has become the very important term. MSCI Group also has the responsibility to realize this kind of social. So that's why we're focusing also on this our R&D to build the CO2 zero emission society. The step that we can perform in here is like this. The first one, we can reduce the CO2 to 65% down by creating or developing the high efficiency natural gas fired turbine. And then if we combine that one with the CO2 capture, then we can make it lower, become 90% down of the CO2 emission. And finally, when the engine itself is changed to become ammonia and also or hydrogen gas turbine, then CO2 emission can be perfectly zero. And this hydrogen and ammonium gas turbine, we are developing in it, and we are targeting to make commercial in 2030, like I shown here. This diagram is actually showing the overall coverage of MHI in hydrogen, ammonia, and also CO2 value chains. I will skip the details about this one, but in here I just want to show that BESS for the battery is one of our solution in overall this carbon neutral society that we would like to achieve. Okay, that's all the introduction, and we go to the main topics in here. So our solution for sustainable power supply with less CO2 emission are as follow. First one, like preparing or like providing engines and also all equipment or technologies that can lower carbon emission. And the second one, to utilize the energy. And then the last one is to optimize the energy distribution. And the battery BESS is including in this distributed energy. Other than this, like a physical solution in here, we also develop a digital solution, which we can probably solve of the part of the solution in it, and we call it energy cloud and autonomy. Later we can I will just explain about this in the next slide. For the battery itself, probably 5% my fellow speakers already explained a lot of things about the purpose of the battery and etc. In here, like we give like three, we can just separate into three, like a generation to smoothing the renewable energy. And the second one is to if you connect to the existing grid, and then it will be like energy arbitrage. And also the last one is for the frequency regulation. In here, honestly, we are same like Wärtsilä. We are not the battery vendors. We are not creating vendors. We are not creating or manufacturing battery by ourselves. But we are offering in here is integrated solution and technology, where the BESS is including in that solution. And then we have also more than 10 years experience in this battery solution business, and we also have the flexibility technology to fit perfectly with the purpose, demands, and condition at the site, and also the requirement from the clients. Okay. And as we are not just a battery vendor, instead of that, we are offering the best solution, the BESS, business development and project execution together with the clients. So what we can propose or can support the clients from very beginning stage, like from the equipment selection, and then we can continue to the system consultation, which including probably feasibility study, value engineering, profitability analysis, and also project development. And then when we go next to the project execution, we can support it as well. And finally, during long-term maintenance, we can also support for the maintenance and long-term services. From our experiences in over the world, we did application of BESS in various cases, which can be divided into 3 examples as follows. The first example is we can connect it to the we can connect to the existing grid. In this case, the battery will be accessed. The battery will act as energy arbitrage, where there's trading between the charging and discharging of the battery depends on the demands of the electricity. The purpose of this one, of course, to maintain and to stabilize the grid, the manual output. And if you saw in the lower left picture in here, our battery solution is not only like a box on containerized like this, and if there's a large capacity that is required, we can make like a more one box for the building like a box in here to minimize the footprint and also to make us more efficient. And then the second application, probably you already know, as a lot of discussion before me. We can connect this one together with the renewable energies, and battery in here will be mostly will act as a smooth to make a smooth of the output, especially for the solar panel and also wind turbine. In here we put like our containerized system, make easier to construct and maintain even in a remote area. In the last case, we can connect this one or to integrate this one with the gas turbine power plant facility. So by this application, the quicker response can be handled by the battery, and that can save fuel of the gas turbine, and it can give the result of CO2 emission reduction as well. So this also can be adapted to a new and existing turbine facility. Okay, explain it in previous slide. We also have a digital solution for this kind of distribution. So we have Energy Cloud and Tomomi in here. So Energy Cloud in here will act to collect the historical data, such as the demand of the power of the electricity, the generated power, weather, equipment, and operation plan, and etc. Then those data will be integrally evaluated, connected to Tomomi, and then Tomomi will do his role as energy management system to optimize the operation of the battery system. So by this system, the energy management system, the battery health monitoring, degradation of the battery, the operation evaluation, emergency support, and etc. can be performed in RMC. When we call it RMC, we call it remote monitoring center, which shall not always be at the site. So it can be in other place. This system also can help the clients to improve their revenue, to have the mobile visualization. You can check in every location, and also can saving overall cost and time. As you may already know that the battery is necessary to support the unstable renewable energy. And then when the renewable energy plus battery to be connected to the existing grid, so energy management system and controller in here is required to manage the power resources. And we see in this drawing, the picture, the resources of the electricity can be various, can be a battery, can be fuel cells, can be an engine, can be PV, can be wind, solar, wind power, or probably others like hydro and etc. So we are not only providing this technology, but also we are providing the technology of the controller in here, what we call it e-blocks. That's why we want to introduce e-blocks in here. Okay. We have developed e-blocks. We call it e-blocks. This system we call it e-blocks, and this one is technology to manage the 3 power resources: battery, engine, and also PV solar. So, which can contribute to the electrification in off-grid area with a stable power supply, while it can still reduce the CO2 emission. MHIET, we call it MHIET. This the group company that handled and developed e-blocks. And e-blocks diagram, or just like a scheme, basic scheme can be seen in this picture. So there's a connection between the PV, battery, and engine, and this 4D, the control panel, will manage which should be the main power. Depends on the situation, especially for the weather, and also like the night and day and something like that. And when there's some excess, the battery will be charged, and when there is no power supply and then or sudden change, then battery can discharge their electricity, something like that. So this kind of system that can have in e-blocks. And then this triple hybrid, we can call it this triple hybrid. We already successfully and installed in our own in our plant in Sagamihara, Japan. Oh, this is the picture of it. This one is exactly previous presenters already explained about this one. So when there is a PV power supply, a lot of the fluctuation in here. And then when there is a rainy and then there is no sunlight, and then something like this. So this fluctuation can be fixed by the battery, and this lower area can be fixed by engine generator. And those can be managed, and the stable output can be put from here. But this one is the e-blocks function that we can give. And e-blocks application exactly is not only for the off-grid area, it's like a small town or remote islands, but also for industrial park and possibly and also for the power of supply of mining site. Okay.
Yeah,
and
Ahmad.
Yep.
I think we still have 2 more minutes for the presentation.
Okay. Thank you. So we, as one step of we also have the path to the CO2 zero emission by this kind of e-blocks. So when we want to put renewable energy, we cannot just drastically change from the conventional into the new renewable energy. We have to do like a step by step. And this application of e-blocks is also one of the steps that we can achieve to achieve zero emission. The first one, so by this e-blocks, so we can reduce the CO2 emission by managing all the things correctly and optimizing all the things. And then by this genset, or we can call it the engine, when the engine can be changed into the hydrogen engines, then the CO2 emission can be make it totally zero. That's why by this kind of the thinking way and the direction, we also we are also developing the hydrogen engine. Yeah. So this engine is actually we already successfully running it in 100% hydrogen, but in one cylinder. And now we are aiming to create a 1 megawatt scale of the hydrogen engine, and we are targeting to be commercialized in 2030. That's all from the explanation from myself and explanation from Mitsubishi Group. I will return to moderator. Thank you.
Yeah, thank you, Pak Hikam, for the presentation. I can highlight some of the points in the presentation from Pak Ahmad, that Mitsubishi has contributed up to 17 gigawatt of installed generation capacity in Indonesia, which is around 30% of the total in Indonesia itself. And Pak Ahmad also presented that the application of grid-scale BESS can help for grid stabilization, smoothing the variable renewable energy ancillary service. But the interesting one is for the black start, especially for the hybrid system with gas turbine, as explained during the presentation. And the other one is for the power quality improvement. Pak Hikam also mentioned about the e-blocks, which is interesting that he explained that the path to the zero emission must be achieved step by step. So we cannot just get the zero emission, but we have to achieve that step by step. Pak Ahmad, really appreciate your and MHI experience sharing with us. Thank you for the presentation.
Thank you.
We move to our last presenter today, Mr. Oh Dae-il from LS Electric, South Korea. But
good afternoon.
Before that, good afternoon, Mr. Oh. I remind that the audience can submit the question through the Q&A box on Zoom or via live chat on YouTube at any time during the presentation. Please don't forget to mention your name and organization and to whom the questions are intended. Mr. Oh Dae-il from LS Electric presentation will talk about ESS trend of technology and application. Mr. Oh Dae-il career in sales division started in 2015 up to 2019 as Chief of Representative Office in Indonesia. Then in 2020 until now, he is the sales manager in Smart Energy Global Sales Team at LS Electric. Okay, without further ado, I would like to welcome Mr. Oh Dae-il to deliver the presentation. So Mr. Oh, the Zoom is yours for 15 minutes, please.
Okay, thank you. Okay, can you see my presentation data?
Yes, clear. It's clear.
Okay. Okay, thank you for giving us the opportunity to introduce ESS-related technology and market trend. My name is Dae-il Oh from the LS Electric. I had worked the Chief of Representative in Indonesia from 2015 to 2019. And now I'm working in Smart Energy Division after coming back to headquarters in Korea since 2020. Okay, today I prepared 4 sections to introduce as above: LS introduction, energy storage system overview, and ESS trend of the technology, and last ESS market. As you can see the data, LS Group spun off from the LG Group in 2003, and we are leading in the field of electric power, automation, and machinery, material, and energy in global. LS Electric has many EPC and O&M reference in their ESS field. Producing it, we are own PCS product, electrical equipment, and working with all battery manufacturers to carry out their project. Okay, I will explain the global market change and application for ESS. There are several storage systems upon the energy type. Physical storage like a pumped hydro and flywheel. electromagnetic storage like a superconductor, working at very low temperature, using state of matter like compressed air or thermal storage, and last but not least, chemical storage like battery. Energy storage technology has been developed throughout the years according to their demand in providing stable electricity to their grid efficiency. Today, I'm going to focus on the battery energy storage system, BESS. BESS can be used for various purposes, and the characteristics of battery technology were capable enough in generation sector and transmission and distribution sector, and even CNI and BTM market. Of course, the investor only what matters is how much it is on cost effective and worth investing. Okay, ESS trend of technology. This is configuration of BESS. As you can see, BESS composed of the rechargeable battery with BMS, PCS, PMS, and power devices for on-grid. This is system of the BESS. Okay. PMS is an essential technology of the ESS system. PMS, which serves as the control tower of the ESS, is software that adjusts the amount and time of the charge and discharge of the ESS throughout control of the battery. It is a system that analyzes charging and discharging data of the ESS in the conjunction with sensors and measuring equipment and control ESS to operate at optimal efficiency. One of the PMS application is load leveling for industrial use and stabilizing for renewable energy. Load leveling and peak shaving use ESS for electricity cost reduction and avoid significant investment such as additional plant construction. Renewable integration is for renewables output stabilization and peak load reduction during the nighttime. Many changes are taking place in the Vietnam solar market now. Investment continues to increase with the aim to charge 5 to 15% of the power generation with ESS and discharging it after 6 p.m. This is a renewable. After 6 p.m. due to the current problem with over solar power generation, it calls the curtailment issue. The three projects below are Korea Electric Power Corporation, called that the CAPCO. The ESS performance conducted by RS Electric. Korea also manages the power grid at state-owned company like BESS in Indonesia. RS got this project and constructed them. Example, in the UK and Australia, the frequency regulation market is operating separately. Philippines rapidly increasing ESS ancillary service project in power plant. The frequency regulation market will continue to expand under supervision of the power authority. As for smoothing control, RS Electric has experience in the Hokkaido Solar in Japan, in the ESS project. When the Japan Electric Power Agency transmitted grid power to renewable power generation, it needed to operate within a specific frequency. There is no such policy in Korea, but there is a special policy in Japan. But I think there will be a need depend on the national policy in the country. Microgrid in the on-grid type is for the stabilization of the renewable energy and isolated grid. It is for constant power on renewables and ESS supplies power for the grid. This is kind of the two type, normal operation function and isolated function, you can see. Then the main purpose of the microgrid, off-grid type, is to minimize diesel generation by renewables and ESS isolated power system. It can be stabilization for power systems such frequency regulation. EMS control the renewable energy output. RS Electric has experience of the microgrid or off-grid type projects in Korea. Voltage control on distribution system is an additional feature in ESS. It is to secure capacity reserves and voltage of power distribution line. ESS discharges electric power to decrease the voltage level of the power system under peak load condition and charge electric power under low load condition. Emergency generation is an ESS function that is applied in the factories and buildings. Typically, ESS is using at the load leveling, but in the event of the blackout, ESS operate to recover critical electrical facility in the building quickly, such as lighting and elevator. ESS replaces diesel generators as facility for stable electrical operation and emergency response. It will be used widely for emergency electrical recovery in general building and factory. Okay, I'm gonna talking about the ESS market, especially Korea. As you can see, ESS market in global and Korea, ESS system have been widely installed in South Korea from 2017 by RPS, REC, Advantage for Renewable Integration and ESS Incentive Program for large commercial customer. In particular, Korea Renewable Power Company invested 7.5 gigawatt ESS in power plants from 2018 to 2020. In addition, government provided incentives for REC weight. You can see in there this REC weight to IPP up to 5 times of the amount of power generated. And the ESS market in Korea grew quite hugely. Okay, as you can see this graph for PV and ESS, charging during PV peak time can earn the highest REC weight and also eliminate rapid power voltage swing. It is optimized connection capacity during PV peak hours and allow more PV generators to be online by avoiding transmission line and distribution congestion. Okay, this is a ESS incentive program for C&I market in Korea. Electricity rates are set differently by time, which has led to growth of profitable business in the ESS using the operation. It is a structure that changes energy in the early hours of the morning when electricity is not used much, and discharge during the day and night, which are on peak. Okay, the RS Electric has been the power system business for more than 40 years. We are manufacturer and carry out business in the global standard, all equipment and materials needed for the electricity. There is also office in Indonesia, and technical support is available there. In addition, we are conducting the ESS business directly with SI, system integration, and EPC, and working with battery manufacturers in Korea and China. Okay, last, this is a share for information. As you can see, the Global Energy Strategy Outlook 2021 from the Wood Mackenzie. Asia market have huge potential to grow after 2025 due to increased power consumption and peak demand. Solar and Solar Plus and ESS has significant potential to replace diesel in countries that have hundreds of isolated islands like in the Indonesia. Also, battery costs are still high in the Southeast Asia, but the supply chain issue may be solved in Indonesia. I heard in one of the biggest battery manufacturer, LG Energy Solution, will make the factory in Indonesia. One of the biggest battery maker in China, CATL, will make the factory in there. Okay, this is the end of my presentation. Okay, thank you.
Thank you, Mr. O'Dale, for the interesting presentation, sharing how South Korea deploy the energy storage system through some program. One of the interesting point from Mr. O presentation is about the South Korea ESS market. ESS have been widely installed in South Korea since 2017 through some programs, such as
kind of the government program. Policy.
Yes, government program, RPS, REC, and some incentives.
Yes.
For large-scale commercial customers.
Yes.
I think that's why because of this kind of programs, then ESS becomes necessary if South Korea wants to improve the renewable energy penetration more and more.
Yes.
And also for the incentive program, I noted that this kind of incentive can encourage the commercial and industrial sectors to shift the energy consumption from grid during the peak load period are also effective, I think. Once again, thank you, Mr. O, for the nice presentation.
Thank you.
Okay, ladies and gentlemen, now we have our second Q&A session. We are now going to take some questions from the Q&A box, and here we invite Mr. Febron, Pak Febron, and Pak Ahmad Hikam, and Mr. Odeil to switch on the camera so we can. Okay, good. All right. And now I will try to. Okay, wait a minute. Okay. So our first question is for all presenters. So this one is for Pak Febron, Pak Ahmad Hikam, and also for Mr. O. This one posted by Hendrik Haryono from PLN Surabaya, UPT Surabaya.
Okay.
He asked about how about interoperability for your product, including software and hardware, when combining with an existing system with different brands, maybe different maker.
I want to explain for our business scope, because of the ESS business is not only for the material, because in the but also like yes, go ahead.
I think Mr. O, I think this one question is for all presenters. I think we will start from Pak Febron, Mr. Febron first. And then we will have you the chance to explain about the interoperability as well, right? Maybe we can start from Pak Febron and then continue to Pak Hikam and Mr. O. Please, Pak Febron.
Thank you, Pak Fauzan. And also thank you to Pak Hendrik Haryono from PLN UPT Surabaya for the question. I think it's a really good question. Actually, during my presentation, the question is already answered. because when I present the case study, like in Azores, Portugal, actually the engine is a Caterpillar, it's not a Wärtsilä. And actually also the other Bonaire, I think, if I'm not mistaken, is also not Wärtsilä, it's a MAN engine. So Wärtsilä GEMS or energy management system is capable to integrate all the assets, whether it's renewable energy, battery storage, engine, thermal. So I think it's no issue. And in terms of operability, I think our GEMS software is really friendly, friendly to operate. Because if you, I think from the video, actually, you can see also that weather forecast is already included. So a lot of data included in the GEMS to provide the optimized operation, so that more and more renewable can be penetrated. I hope this answer the question from Pak Henry Karyono. Thank you.
Thank you, Pak Ferron, for the very clear answer. Yeah, I think I saw that in the presentation as well. Maybe we can continue to Mr. Hikam, please.
Okay, thank you very much for the question, and very interesting question as well. The same question probably with Pak Febron, Mr. Febron. So yeah, we are not the specific manufacturer of specific items like battery itself. We are not the manufacturer of it. We usually use other and looking for the best solution for the clients. So it's mean that we don't have any restriction of the how we will use which brand that we can use or something like that. So it's open. That's all. Thank you.
Yeah, very clear, Pak Hikam. Thank you. Maybe Mr. O, how do you think about the interoperability of the LS Electric product, GSS product? Please.
Yes. We are not a battery manufacturer, but we made it all in the electric equipment. It's kind of an electric component, low voltage, medium voltage, and transformer up to ultra high voltage substation. And we have we have a solution for the EMS. It is an essential solution of the ESS because of it's kind of in the EMS system. Because of all the function and application is controlled by PMS, but we have our own technology. Of course, in kind of ESS investment, is first priority is the cost. Of course, as I explained, still battery still expensive, but in the battery will be cost down. Then ESS will be more booming. Yeah. Is my
Thank you, Mr. O. I think we all have same answer, right? Because in this era, I think everything should be able to interoperability with other system, right? We cannot just buy our product or our manufacturing. Okay. The second question is for specifically for Pak Ahmad Hikam of Mitsubishi Heavy Industry. This one is posted by Ms. Bahul Munir. The question is, please explain about the cost and benefit analysis of Mitsubishi BESS if they are used for storing high voltage energy, for example, from 150 kilovolt or 500 kilovolt transmission. Yeah, please, Pak Hikam.
Okay, thank you very much for this challenging question, I think. Honestly, the cost and the benefit will depends much on the actual sites and actual condition and also the requirement of the project. So honestly, I really apologize that I cannot say any number right now, and I cannot promise you anything for right now. But we are willingly happy to hear more details on the background that you are question of. So we can understand. So based on your explanation more on the background, probably we can understand more the condition or probably your requirement or probably your thought or something like that. So don't hesitate to call me or to send me email about the details of your background of the question. I will send my email to your private message.
Yeah.
Thank you.
Yeah. Thank you, Welcome, for the short and clear answer. And the next question is, this one is for Mr. O from LS Electric. Yeah. The question is, it is interesting that South Korea can successfully accelerate the deployment of the renewable energy as well as the battery energy storage system through some programs like RPS, REC, incentive, and etc. The question is, how different is South Korea power system and market compared to Indonesia, in your opinion? And also, what do you think? Is it possible for Indonesia to, let's say, copy or imitate such program to accelerate the deployment of the BESS or not? Thank you.
Thank you for the question. I will explain what is the difference to Korea and Indonesia. Especially Korea, we have two major manufacturer. Oh no, now it's three major manufacturer, battery manufacturer in here. It's kind of the Samsung SDI, LG Chemical, LG Energy Solution, and SK Innovation. In the government, they want to make it the booming to use the battery and ESS system. That's why government make some kind of the policy incentive, the support from the government. That's why in terms of the investment, it kind of the renewable. It's the government spend the money and support it to the renewable market and battery manufacturer. That's why it is kind of the investment from the government. And second is what is the different Indonesia and Korea? We are different tariff of the off-peak and on-peak time and off-peak time. It's kind of in the peak time is the night and the daytime, special kind of the time. And it's kind of the early morning, kind of the 2 to 6 a.m. is quite low price, the energy and the tariff. That's why in the factory and industrial want to keep it the electricity, the cost. That's why in the low cost electricity time, the charging, use the charging ESS, and the peak time is kind of the double price. They use the ESS discharging in the factory and industrial. But I heard Indonesia there is no in the kind of the different tariff.
Tariff, yeah.
Is that their answer? Correct?
Yeah. I think that answer the question. I think it's quite different between the market in Indonesia and South Korea. So I don't know if we are able to go to that kind of market system. All right, the next question is for Wartsila, Pak Febron of Wartsila. This one from Anonym. The question is it possible to expand the install capacity of the battery with other battery? Maybe he meant with different brand, I don't know. If not, is there any technical reason? Yeah, that's the simple short question.
Thank you, Pak Fauzan, and thank you also for the question from Anim. Actually, to increase the install capacity of battery also depend on I think some other presentation speaker already discussed it, because there is we call it augmentation, that as we know that battery will degrade during the time, and with the augmentation it can be increase the capacity. But as we know, not only the brand of the battery itself is different, but the type of battery is also even it's a lithium ion, but still there is LFP, MC. So
MNC.
Depend on the use case also. So it is difficult to give simple answer. So we need to understand first the use case and whether the battery is also compatible, each type, also its brand. I hope this answered the question. Thank you.
Yeah, thank you, Pak Febron, for the response to the questions. I think this one is the last one intended for Mitsubishi, Pak Ahmad. Yeah, actually this one is from my friend. Pak Ahmad, one of the interesting topic you delivered is about the energy management system. I noticed that Mitsubishi can perform data analysis with AI, artificial intelligence, through energy cloud, Tomoni, etc. And the question is, how Mitsubishi can perform such analysis using AI technology in Indonesia power sector? Because as far as I know, our data management is not quite good at this time in Indonesia. But for using AI, as far as I understood, we will need huge data or big data. Please share your opinion and how Mitsubishi solve this challenge in Indonesia. I think this one is also interesting. I like to hear the answer from Pak Febron and also from LS Electric also. Yeah, because I saw in Pak Febron presentation also there is kind of the AI machine learning GEMS management system also in LS Electric, but this kind of technology will require huge data, right? Big data, so-called big data. But in Indonesia, you know, we don't have that kind of data, I think. Yeah, please, maybe from Ahmad first.
Okay, probably Pak Febron want to say something first. It's okay. Okay. If they ask me, yes, I understood the question, the condition in Indonesia that the data is not so well and not so well collected in something like that. But yeah, that one is our challenge as well. How much that you can predict by our AI based on insufficient, you can call it insufficient data that we have right now. Yes, of course, if you want to say about AI and etc. like that, something like that, then the data will be important, the input data especially. But that kind of things that we can achieve, not, of course, not directly right now, but gradually. So hopefully we cannot, of course, we cannot expect 100% successful for the first time application. But gradually, probably we can collect all the things, all the data that we can have, and probably revising the data that we have, and then we can make a better, probably first 50%, and then better and better, something like that. Probably that's my answer, and hopefully that can answer your question.
Yeah, thank you, Pak Hikam. Maybe we can go to Pak Febron.
Thank you.
How do you think Mitsubishi? Wärtsilä? How do you think? Yeah.
Of course, yeah, we use also artificial intelligence and also machine learning to our energy management system, and this required big data. But I think we can use also, the available data such as the weather forecast to predict, to optimize the use of solar PV depend on the sun and or the wind turbine depending on the weather forecast for the wind. And from the generation side, of course, this energy management system will be connected directly to the assets, whether it's engine or renewable. And again, then is another side is the load. Of course, the load is also fluctuating, but I think this data can be provided by the dispatch center. So if it's connected to grid, of course, if microgrid is a different story. But with the available data, it should be capable to run GEMS, successfully. Thank you.
Yeah, Thank you, Pak Febron, for the answer. Maybe you can go to Mr. O. Deil. How do you think about the AI things in the power sectors? But we have insufficient data, as Pak Hikam said. Yeah.
I think I can say there's not enough to answer, but I will try. And the AI data is in the future will be needed. The quite essential the function and the technology because of now the ESS data also quite important, and so using the customer use the cloud or some kind of the big data used because of the data is quite essential in the maintenance, the battery and charging and discharge. It is not from in the local, but also overseas because of in the case of the project, we are considered to monitoring from the Korea to UK. But we are monitoring from the Korea. That's why the data is quite important. But in the future, AI will be stored and alarming and maintenance by themselves. But I don't know. I have no idea. So.
Yeah. All right. Yeah, thank you for. Yeah, I think we should start. How to say manage our own data in power sector. Yeah, in Indonesia, I think as Mr. O said that it will be very essential in the future. Yeah, I think we should start there. Okay, I think that one will close the Q&A session. Our second Q&A session for this for today's webinar. Thank you very much, Pak Febron of Wärtsilä, Pak Ahmad Hikam of MHI, and Mr. O from LS Electric. Thank you very much for sharing with us and for the presentation. Thank you.
Thank you.
Thank you, Pak.
Okay, we are now at the end of the our webinar session. Yeah, if you still have questions that we didn't have time to answer on today's webinar, you can please contact the speakers at the address shown in their slide presentation. Yeah. The electronic certificate and the presentation material will be sent to your email within 5 working days at the latest. So don't forget to fill in the attendance form so we can share the certificate and the presentation materials. Also, we have recorded this webinar on YouTube channel. You can find MKI IEPS. So please take a look at the YouTube of this recorded webinar. Thank you for our speaker today, Mr. Toto Nugroho, President Director of IBC, Mr. Nitus of EGAT, Mr. Jingkang of Huawei, Mr. Rahul Mehta of Hitachi, and Mr. Odeil of LS Electric. Yeah. And thank you everyone for attending today's webinar with the title of Unlocking New Business with Battery Energy Storage System. And lastly, yeah, I got a message from the organizing committee. We shall have again a photo session with all the speakers. If you are still with us, hope you don't mind. Maybe all of the speakers can turn on your camera for a while so we can take a picture together. I check Mr. Gui, Pak Febron, Mr. O. Yeah, Mr. Rahul, are you still with us? Maybe you can turn on the camera.
Just give me 1 minute.
All right, no problem. Okay, Mr. Gui is already there. Mr. Nitus, I cannot see. Maybe he has left it. Okay, all right. Maybe the operator stand by for the taking picture. Oh wait, please wait.
Okay.
Okay. Okay, good then. Please, operator, I will count down 3 to 1, and we can stand by, freeze for like maybe 10 seconds. Yeah, so the picture will be good quality. Okay, 3, 2, 1. Okay, good. Thank you for the presenter, the speakers, ya, Pak Febron, ya, Pak Ahmad Hikam, Mr. O, Mr. Mehta, Mr. G. Jingkang, and Mr. Nitus, and also Pak Toto Nugroho as the keynote speakers. All right. As mentioned earlier, today's webinar is the 4th episode of MKI Smart Grid webinar series out of 10 episodes hosted by the Indonesian Electrical Power Society, Masyarakat Ketenagalistrikan Indonesia, or MKI, taken place from April 2021 until January 2022. And this webinar is supported by PT PLN Persero. And this webinar is sponsored by Tide, Huawei, Capco, Hitachi ABB Power Grids, Siemens, ABB Sakti Industry, Trilliant, GE Grid Solutions, Mitsubishi Power, PT Indonesia Comnetworks, Icon Plus, and in partnership with Think Smart Grid Friends and Energy Academy Indonesia, EGAT. On behalf of the Indonesian Electrical Power Society, Masyarakat Ketenagalistrikan Indonesia, or MKI, thank you for joining us today. We hope to see you all in the next episode of MKI Smart Grid webinar series that will be held on 12th of August 2021. With the title of the webinar is Wide Area Measurement, Protection, and Controlling. We will keep you all updated on the detail via email. Thank you all and have a great rest of your day. Thank you.
Thank you.
Thank you. Thank you.
In live Pak Fauzan.
Ya, sama-sama Pak.